Welcome to SciShow Tangents. It's a lightly competitive knowledge showcase. I'm your host, Hank Green, and joining me as always this week is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hi there.
The question that, of course, is weighing on everybody's minds is if you had $50 billion to buy any company on Earth.
Don't talk about it.
All right. Here's the actual question I want to ask you.
Yeah.
If you had to buy any company, the name of which I would recognize and that the people at home would recognize. So like a company that's a household name, what company, you were forced to buy it and you had the resources to buy it, which company would you be like, that's mine now, y'all?
I know what I would do because I fantasize about it all the time. So when I was a kid, cable TV was cool. And that like at night, like weird stuff would come on and they were just doing weird stuff all the time on cable TV. Like up all night movies with hosts and just like morning shows with puppets and stuff. So I would buy like FX or something or like TBS or like one of those like lesser cable channels. And
some cable channel that like isn't doing particularly well anyway. And you just like could put whatever you want on it for 6 months before you went bankrupt.
And I would treat it as my own like public access television channel.
Just get the weirdest. Sam, that's not a terrible idea. I really like the idea of a Netflix or a cable station that is really just the weirdest stuff. Like that's what's binding it all together.
It's what's missing in the world these days. Is like just that very like specific weird voice. Everything has to be so marketable now. Not for me, man.
You want Dr. Demento on TV.
Exactly.
Yes. All right, I love that answer. Sari, have you had thoughts?
I was trying to think of something like funny or clever. But I think Costco. I like the idea of being the guy to offer a $1.50 hot dog to other people for the rest of my life and just be known for that. Be like...
You could just get a hot dog stand.
That didn't even occur to me. I thought the Costco food court.
Is it just the hot dog part that you like?
I like the Costco food court. I think that's a great part of Costco. The rest of the business, fine. It seems like a lot of work. Seems like a lot of logistics. But running an affordable food court for people, that seems nice.
I think about that sometimes. Where it's like I just want people to have easy food, and because it can be quite hard. Especially to get good food. And I don't think a hot dog is necessarily sort of the pinnacle of the health food. But no, okay, this is my idea. This is what I'm doing. I'm going to buy any fast food restaurant chain. Anyone that has a lot of locations. And they also have to have equipment for cooking food.
Okay.
And then I convert it into, I'm like, no, you don't get hamburgers anymore. Instead, you get pre-made meals that are refrigerated. And you just like come by. And there's only one thing a day. You get whatever we made that day. And you come by and you pay $3 for it. And you don't know what it is. Or you can look at the phone.
You
whatever.
should know what it is.
You can, it'll say on the board. It'll be like lasagna a la Hank on it. And then you'll know that it's like, I like that lasagna. That is Hank's favorite lasagna.
Will everything be a la Hank?
It's called, the restaurant's now called, I'm going to buy McDonald's and I'm going to turn it into a la Hank. and it's just like pre-made, just like throw it in the microwave, but it was made fresh and it's got fresh ingredients and it's good for you.
Oh, that's nice.
Will people know what they're ordering, or will they drive up and be like, I'd like a double pound, like quarter pounder with cheese, and then you just get a la Hank, lasagna a la Hank.
It's enchiladas. Turns out, welcome. You wanted a cheeseburger? Stew.
Yeah.
Oh no, that's so disappointing.
You wanted hot fries? You get
a cold paprikash. None of us wanted to run the company as it existed. We all wanted to take the thing,
radical changes,
and just do the thing that's interesting to us.
Yeah.
Sari
wanted to get rid of about 99% of her company. In fact.
I mean, I would keep it around. I'd just give it to someone else. I'd be the eccentric
I'm not
rich
good at
person.
this, but I am going to be good at hot dogs.
Yeah.
Oh, $50 billion is a lot of money, you guys. But anyway, instead of talking about that, let's introduce what the heck we're doing here. This is a show called SciShow Tangents, where every week we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic. Our panelists are playing for glory and for Hank Bucks, which I will be awarding as we play, and at the end of the episode, one of them will be crowned the winner. Now, as always, we introduce this week's topic with the traditional science poem. This week, from all of us, because right before we started recording, I said, is this episode not about paper? And you said no. And I said, well, I have a great poem about paper. And so we had no poem until 8 minutes ago. And then we all went offline and we wrote our own tangents poems. Who goes first?
I think you got to go first.
Oh, well, mine's so bad. I took the longest and I don't think it's good. Okay, here it is. These little things always are squirming, but people think that they're vermin. But I say, hey, they're really great. Those worms, they're just worming.
That was it.
It took me 3 minutes.
It took you twice as long as me and Sari took to write our poems. Okay, I'll go next because I'm excited for whatever Sari has cooked.
Okay.
I don't
sick mind.
Okay.
It's time to learn about the worm. In the ground they squirm. They're squishy, not firm. Though they're nasty, don't spurn those slimy, lovable worms.
Good.
Kind of similar to your poem, actually.
Yeah, I think we may hear squirm a third time. It's possible.
Oh, I didn't put squirm in mine.
Oh, wow.
I was not using rhyme zones, so my rhymes were severely limited. There once was a little long lad who wiggled around and looked sad. He ate lots of junk, then pooped it out of his trunk to feed tomatoes for your dad.
Wow, nice. We both did limericks.
Yeah. I have 2 more stanzas if you want them. They get worse as we go.
Are you serious?
Wow.
You had 90 seconds? Okay, keep going.
Yeah. There once was a tube in a vent, all hot and slimy, the gent. He has no backbone, but he does have a home in the deep sea. There they went.
That was so good.
Okay, one more.
Okay.
There once was a wiggly worm, not a twig or some yarn or a sperm. They are soft and wet and sometimes a threat, but they'll be around for the long term.
Oh my God. Do you want to hear again what it took me 3 minutes to write while Sari did that in 90 seconds? These things are always are squirming. Some people think that they're vermin, but I say, hey, they're really great. Those worms are just worming. That's what I did in 3 minutes.
But I say, hey.
Yeah, well, that part really throws me.
Yeah. Oh, Lord. Well, the topic for the week is worms. Sari, what is a worm? I know the answer to this question.
Oh,
no such thing.
There is no such thing. It existed a long time ago when we were still figuring out animals. Then Carl Linnaeus in 1758 said, I'm going to come up with a class. I'm going to call it vermes. And I'm going to describe it as any invertebrate that's not an arthropod. So not a scorpion, like the plated outsides or whatnot. And he's like, anything kind of squishy and small, that's a worm.
Could it have legs back then?
It's destitute of ears, nose, head, eyes, and legs.
Okay. That feels like it's from a science poem right there.
Yeah.
But it turns out that this body plan is common and useful and has been converged upon many times.
Mm-hmm. Yes. And so now we know that there are any number, a large number of phyla that are various different worms. There are like annelids or nematodes or platyhelminthes that all have the same body plan of long, flexible, either round or flat, kind of squishy, no obvious appendages. If they are, they're really small. And they eat a bunch of junk. Usually they're part of the decomposing part of the ecosystem.
Mm-hmm.
Yeah, I like to think of them as just an intestine with a mouth.
And if you have one in your intestine, then it's just an intestine within your intestine.
And it does happen, doesn't it?
That happens too.
But worm is just a slang word at this point. Is that accurate?
Mm-hmm.
Yeah, there are lots of things that are called worms, and it is not a taxonomic group.
Okay.
Yes, it's more of a catch-all term. And it's even used to describe species that wouldn't be that don't fall anywhere taxonomically as worms. So like Sicilians, the legless lizards, are sometimes called worms because people looked at them and were like, oh, you're long and squiggly. That's a big worm.
That's a big old worm, isn't it?
Yeah. And etymologically, worm was also kind of a nickname. Just started from the root wer, W-E-R, which means to turn or bend. And that informed so much of our language, from like awry to vertebra to wrinkle to wrist. Just all kinds of words stem from this to turn or bend. Then worm as a word, W-U-R-M or W-Y-R-M, was interchangeably used for pests, like any sort of thing, starting from insects to wiggly worms, but also to like a small snake or like a reptile you didn't like. And that's how worm became used for big snakes, aka dragons. And so it just like kept snowballing from there. And then at some point, I really, really tried to look into the etymology of dragon, because when we did our dragon episode, I wasn't doing this segment, but it seems like it comes from the verb draco, which meant to glance. And so like the word dragon came from piercing eyes and like a glare that a creature would give to you, like a malevolent spirit or something. And worm described like the annoying pest or like the things that you didn't want to be around. And then for a period of time, they were both used kind of interchangeably. Like people called fictional dragons worms or dragons. But then as the words were used more and more, then people were like, well, we've got to have a difference between them. And so worm became small things and dragon became the mythological beast that we think of as dragon. And the rest is history. We just decided at some point. Like,
I feel like we made the right call. I feel like worm. I'm like, that's a worm, that's a dragon. Like put the thing and the word, and if I've never seen either of those words or either of those things, I'd be like, zoop zoop. I know which one's which. That brings us to the quiz portion of the show. This week we're going to be playing an episode of This or That. So in the 1960s and 70s, scientists took the 1 millimeter long nematode known as Caenorhabdus elegans and developed the techniques for raising and studying this worm that would turn into an important model organism along with others like E. coli and fruit flies and zebrafish. So you know about C. elegans if you do much work in biology. In addition to being the first multicellular organism to have its genome sequenced, C. elegans has made many other important contributions to science thanks to its simplicity. So today, in honor of this model organism, we're going to be playing Worm or Not. I will describe a scientific discovery made with a model organism, and you have to guess whether or not that organism was C. elegans or some other model organism. Does this make sense to you?
Yes.
Would you like to play the game?
Yeah, sure.
This organism seems to love cancer cells, so much so that scientists created a device that would use the organism to detect lung cancer. The device is made up of a chip loaded with liquid media that had been around either normal cells or cancer cells, and at the other end is this organism, which can confirm the presence of cancer cells by traveling toward them. So it just loves cancer cells, and so it moves toward them, which is an amazing cancer detector. So, worm or not?
Are cancer cells yummy is the question, I guess, to C. elegans.
Purely vibe check here. No,
yes.
It ain't C. elegans.
That's a vibe. That's just like going on your...
Yeah. They don't want anything to do with that.
In my head, C. elegans swim. And so I feel like it would, if you put a bunch of cancer cells in water, then it would all diffuse. And so I also don't think it's C. elegans.
You are both incorrect. Cancer cells have a smell that is distinct from normal smells, and there are dogs that have been even trained to smell cancer cells. But dogs are big, and they require training and a lot of food, and you have to clean up after them. So scientists wanted to see if they could use another animal for the same purpose, and it turns out C. elegans are, for their own mysterious reasons, drawn to the smell of lung cancer cells. In previous work, researchers found that When faced with a choice between different drops of human urine, the worms tended to move toward urine that came from cancer patients. They are specifically drawn to 2-ethyl-1-hexanol, a molecule known to have a floral scent, maybe because it smells like food, though the exact reason is not known. So scientists created this chip with little cancer-detecting worms in it and found that they were 70% effective at sniffing out cancer cells.
Wow.
Wild. 70%, not really good enough for clinical use. Gotta train these boys up.
Mm-hmm.
Yeah, keep practicing worms. Come on.
Yeah. This or that number 2. To test the toxicity of a chemical, scientists devised a method that starts with mixing the chemical with cow feces. Then they added 10 eggs from this organism to the mix, and then they waited for the eggs to hatch. After hatching, the individuals are monitored to see whether the chemical added to the poop has affected their development and morphology. So this is a toxicity test. Was it, though, worm or not?
I'm going to say worm because the last one was about pee, so why not throw them in poop too?
I'm going to say not worm. I was probably misunderstanding somehow, but it seems like these guys are in poop all the time, so just be like, who cares?
Well, they added a toxin to the poop, so they want to see this is how they figure out if the
we're not worried about
it. C. elegans, toxins can't affect me.
Yeah.
I'm too simple. Well, Sam, you're right. While there are toxicity methods that use C. elegans, this particular technique is done using eggs from the yellow dung fly. The yellow dung fly is also a model organism used to study sexual selection, but its eggs are used as described to study the toxicity of different chemicals. Last one, you guys. So despite the fact that this organism doesn't have any of the necessary tools to detect light, it is still able to avoid short wavelength light. When looking into how they do this, scientists found that this organism responds and then spits out chemicals produced by the light, like hydrogen peroxide. Light hits it, and then it can spit out the chemicals that are produced by that light, so it is able to detect it. So, but is that worm or not worm?
What
Weird.
the hell? What do you mean produced by the light? Like,
yeah, apparently there's a chemical reaction that happens with some compound in the body that produces hydrogen peroxide.
Yucca. That seems so weird. That's gotta be my boy, C. elegans.
Yeah, I'm going to say it's the worm. They're kind of translucent, so I could see light getting in there.
Stuff's going right through them.
Yeah.
Yeah. Well, you are both correct. C. elegans does not have eyes or any light-absorbing molecules, but it is able to avoid short wavelength light thanks to its response to chemicals like hydrogen peroxide that get produced when other compounds react in their bodies, react with lights. When the worm detects those compounds, it will reverse its direction, and it will also spit the molecules into the environment because it's like, I don't need hydrogen peroxide in my body right now. While studying this process, scientists realized that the worms use their neurons to control subregions of individual muscle cells in the spitting process. And this is interesting because the general assumption is that the smallest thing a neuron can control is a single muscle cell in its entirety. But C. elegans spitting show that they might be able to get even smaller than that to control specific parts of a cell. So like a neuron not controlling a whole cell, but just a bit of a cell.
Weird.
What are they? They're just.
What are they?
They're
figuring it out, man.
Okay.
They're figuring out how to be tiny and simple and still survive over millions of years of evolution.
Seem like they're doing a pretty good job.
They're just worming down there.
That's right. The worms are just worming. Next up, we're going to take a short break, and then it'll be time for the Fact Off. Welcome back, everybody. Sari's got 1 point. Sam's got 2 points, and we're moving into the Fact Off, where our panelists have brought science facts to present in an attempt to blow my mind. And after they have presented their facts, I will judge them and award Hank Bucks any way I see fit. But to decide who goes first, I have a trivia question. In the 1973 children's book, How to Eat Fried Worms by Thomas Rockwell, a boy named Billy is dared to eat 15 worms in 15 days. More than 40 years later, a man named Paul Rees went to his vegetable patch and dug up what would be, at 15.7 inches, the longest earthworm recorded in the United Kingdom. If Billy had to eat 15 worms of that size, how heavy in grams would his total worm meal be?
He only had to eat 15 worms in 15 days.
Just seems total. Yeah, pretty doable.
1.5 minute, probably.
1.5
seconds,
minute?
faster than I can write a poem.
Would you eat them all at once, or would you eat them one at a time?
All at once.
Okay.
Put them on. Get it over with.
Yeah.
Okay.
Gulp. So then this British guy, what did he do?
15.7 inches. It's the long. If Billy had to eat 15.7 inch worms, how much mass would he be consuming?
Time to break out the old arithmetic.
I'm gonna guess 1,500 grams. 1,500 grams.
100 grams.
Just
we got it in grams, Sam. Do you know how much a gram is?
That's really thrown me off.
I'll convert it. You can give me pounds and ounces or whatever you want.
How many is what was her answer in pounds and ounces?
It's 3.3 pounds of worms.
Well, I won't read you the calculation that I came up with.
Calculate, please. I must know, Sam.
Sam's like 85 pounds.
Well, I thought maybe each worm was 4 pounds. Because it's big.
It's big. It's a big
15
worm.
inches.
Yeah,
it could be dense.
It could be a girthy
but
worm.
I think that they remain quite skinny.
They're skinny. I'm still gonna say it. What did you say? 4 pounds?
3.3 pounds.
7 pounds.
Well, the answer is much less than either of you guessed. It is a mere 390 grams, so that's nearly a pound. It's 0.86 pounds. It's roughly the equivalent of 35 Oreos, so it's a lot.
That is a lot.
But not 3.3 pounds of worms. Would you like to know more about this worm?
I would love to.
It was a common earthworm, so it wasn't anything special. The previous record holder was 12.6 grams. This makes Dave twice as large as that previous record holder. The bad news, the worm's name was Dave.
Is the word... I thought Dave was the
person. The bad news is that Dave did not survive being the largest earthworm, as he was humanely, with anesthesia, killed and preserved in the Natural History Museum.
Poor Dave.
Poor Dave. R.I.P. At least he wasn't eaten, though.
Sarah, that means you get to decide who goes first.
I want Sam to go first. I want to hear his worm fact.
Right, you rat. Geosmin, that nice earthy smell that occurs after rainfall or when you stir up some nice damp earth. And humans, we love smelling that junk, don't we? In fact, as we learned previously on Tangents, when Hank just really went off on how good beets smell, we can detect the earthy smell of geosmin better than we can detect almost any other scent. We can detect it in the air at as little as 5 parts per trillion. So real good at smelling it. Mm-hmm. And it maybe helped like humans sniff out water way back in the day. And it makes dirt smell dirty and beets smell beady. But there is sort of a mystery associated with geosmin. It's made by lots of different organisms of a variety of different species, microscopic organisms that is, but it's not really known what advantage there is in these organisms making it. It doesn't help them eat stuff. It doesn't help them mate or anything like that. Geosmin is, as far as we have ever known in microscopic organisms at least, just a thing that they do that smells nice. That is, until April of 2022, when a paper was released that shed just a teeny bit of light on this dirty mystery. So this research team, first of all, this is an aside, I couldn't find out exactly what they set out to do, but there's this quote from a team lead, Liana Zarubi, and she says that they eliminated many possible hypotheses before finding the thing that I'm about to talk about. So I think they might have just been like, look, we're going to figure out what this stuff does, no matter how long it takes us. And they did, I guess. So anyway, humans generally love the smell of geosmin, like I said, and you would think that worms, of all the little guys in the world, would love it too, because they live in so much dirt. Mm-hmm. But the C. elegans worm, which we were just talking about, to them, this smelly smell could be the smell of death. So the April 2022 paper reported that C. elegans could taste geosmin in their environment and seemingly did everything that they could to avoid areas with geosmin in it and microscopic organisms that produced geosmin. In this case, it was streptomyces. And when mutant C. elegans that couldn't taste the geosmin ate the streptomyces, those C. elegans died. So Geosmin does nothing for the streptomyces, and the geosmin itself is not the thing that's poisonous to C. elegans. It seems to just purely be a warning signal, and one that's beneficial to both C. elegans and the bacteria at that. The researchers stated that they didn't know of any other compound produced by bacteria that was just a warning chemical, like geosmin seems to be. So does this entirely answer the mystery of why soil-dwelling bacteria make geosmin? Who knows? I ain't a bacteria, but there are millipedes that use geosmin to communicate with each other. So maybe it's just like some weird chemical that little guys use to have little conversations.
It's a way for C. elegans to avoid the bacteria.
Yeah. And the bacteria to avoid getting eaten, I suppose. Yeah.
It's like any warning from like a red butterfly that's like, don't eat me, I'm poisonous.
Like a poisonous tree frog or whatever, too. Yeah. It's like, You're not going to eat me. I'm not going to mess with you. We're going to both be okay. And
we're like, sniff, sniff, sniff. We can smell that too.
Yeah.
But completely unrelated to why it is being created.
Seemingly completely unrelated. Do we have any idea why we can smell it so good?
No.
I think you named it the water. Yes.
Yeah. There's like two versions of that question. There's like, physically, is it like extra easy to detect? And so we can just detect it better. Or did we evolve to be able to detect it really effectively and because maybe it helped us get closer to water? Which to me, that seems like a big question mark and not one that we know the answer to. Because I feel like, I don't know, it's certainly important to find water, but I feel like mostly we know where to find water because we live nearby where our ancestors lived and they know where the water is. But
like it wouldn't come in handy for very long because we pretty much have it wired in where the water was, right?
Yeah. Be like, yeah, it's there. We know where it is, but I don't know.
You weren't around back then.
I wasn't. I was not in charge of the evolution of humans. So, Sari, what do you got? What do you got for me?
So we nickname lots of worms based on where they live, presumably because it's an easy way to tell them apart. Earthworms live in the dirt, while marine worms swim in water. Intestinal worms are parasites that live in other animals, and tube worms live in lava tubes. So we got all the categories. And this convention also makes it fairly easy when you find a new wriggly guy somewhere totally unexpected. Like in 1877, when some researchers were exploring Muir Glacier in Alaska and stumbled across ice worms. Ice worms are just a couple of centimeters long and kind of look like loose black threads scattered across glacial ice when they emerge in summer afternoons and evenings. And in fact, they were given the scientific name M. solifugus in 1898 to describe how they hide from the sun during the brightest parts of the day. And since the 1800s, ice worms have been found in snowfields and glaciers across the Pacific Northwest in the US and Canada in concentrations of anywhere between 800 and 2,600 worms per square meter, meaning that there are probably billions of them lurking in each glacier.
Oh.
Which is absolutely wild. There's nothing there. And to make this icy lifestyle possible, they have lots of weird adaptations. They have really high concentrations of melanin in all their tissues to protect from the sun's UV rays, but no eyes or other photoreceptors that we know of. They use tiny bristles to hook onto and squeeze in between ice crystals, which we don't fully understand because the ice is pretty closely packed together, but that might be why they emerge in summer because it's kind of meltier. And they have a very narrow range of temperatures where they can survive, somewhere in between -5 to +5 degrees Celsius.
Wow.
And this works for them because glacial ice usually stays a consistent 0 degrees Celsius year-round, thanks to the reflective surface in the summer and the chemistry of water and insulating snow in winter. And thanks to a combination of some antifreeze proteins and cells packed full of the energy molecule ATP, ice worms are actually most active at 0 degrees and get sluggish as they stray in either direction. At -5 degrees Celsius, they start to freeze and die. And at 5 degrees Celsius, which is around 41 degrees Fahrenheit.
Too damn hot.
Yeah, their membranes start to liquefy, and so those worms melt along with the water ice. And as far as we can tell, ice worms are an important part of the circle of life in these fairly barren glacial areas. They eat things like snow algae or pollen grains.
Oh, and of course, snow algae.
Yeah, you know.
There's enough snow algae to support 800 worms per square meter.
You know, all the watermelon snow. that you just don't see.
I guess.
And they are eaten by small birds that are flying through. But that being said, there are still a ton of mysteries surrounding ice worms. So this is where your question gets into, like what they do while they're buried in ice and we can't see them, what they evolved from, how they mate. And even researchers who have kept them in a fridge for a year without feeding them haven't figured it out yet. They're just like, are these the same worms? Are they different worms? I don't know. They're there. And the people who are interested in ice worms are kind of in a rush to learn as much as possible because as the glaciers melt away with a changing climate, these worms will too.
This sounds fake. This is fake.
I made sure this one wasn't a hoax. This one wasn't added to Wikipedia 10 years ago.
I'm glad to know a bit about ice worms. Now I know not to pick one up because I will heat it up and it will melt.
Yeah. You're like a big fire giant to him.
Yeah. Immediate worm death just at the tip of all of my fingers. You asked one of the things that they don't know the answer to is what they're related to?
I think so. So
I feel like that's not that hard to figure out.
We know their species and we know, I guess, how they got to where they're going. We think they were carried by bird feet. Their species name is Mesenchytraeus solifugus.
They're annelids.
They're annelids. Yes, we know. Okay. We've scientifically classified them, but like how they got there and why they just live in this range of temperatures. So I could have phrased that better, but how they evolved.
Do they like come up to the surface for some reason?
That's what we don't really know. They just do. Yeah, they hang out at the surface at the end of summer days.
But other times they're just like down there between the ice crystals.
Mm-hmm. Yeah, so the researchers who observe them know that you have to go during certain times of the year and certain times of the day if you want to see them. And sometimes you see a couple, but then if you go during the right time, then you see like hundreds and thousands of them just wriggling around.
Whoa.
It's your time to study them. And then they disappear again. And you're like, well, goodbye worms.
There's still so much of the earth for us to understand.
Mm-hmm.
All right. So is it this amazing chemical that we can smell and that may end up being a way for bacteria to warn off worms, and that's the whole reason it ever existed in the first place? Or is it cool little ice worms? Sam's already ahead, and I think I'm going to go with Sam's fact.
Oh, wow.
I feel like that has been a pretty big mystery, and I feel like more of the mystery was solved, where Sari is more like, here's a mystery. I'm like, but I want to know more about it.
Come back in a few years and you figure it out, Sari.
Yeah, exactly. You got to fund some research.
Okay.
Ooh, that would be a fun end game scenario for tangents. We all have to get really rich and just start like
with my $50 billion, I'll fund ice worm research.
Here's what my scientists figured out this week. What did your scientists figure out this week? Oh, how quaint.
Oh, thank you for doing all of the work while we talk about it.
Okay, I thought I would really get you.
You thought you had me?
I thought I had you.
Ice worms.
This man loves Geosmin. That's what you gotta know about Hank.
Well, that means it's time to Ask the Science Couch, where we ask listener questions to our couch of finely honed scientific minds. Oasis on Discord at Blazek and several other listeners asked, it's assumed that worms are good for soil and plants, but I've heard that earthworms are invasive and can harm ecosystems in some parts of North America. What's the real story here? It's both of those things. Mm-hmm. So like worms are definitely good for your garden, I feel like, making softer, good aerated, poopy soil.
That's not true. I don't know what to believe.
Sari, is that true? Or should we? Or is everything up for grabs?
Do I need to go out there and eat all the worms? Get them out of there.
So yes, it is true. Both things are true. Worms are decomposers, and they help. So aerated soil is good both to get gases down there and for water trickling down.
Mm-hmm.
And the castings that they poop out are good concentrated nutrients that don't leach out of the soil like fertilizer. They stick around and provide nutrients like nitrogen or phosphorus or potassium and the other stuff that plants need to incorporate to grow big and strong. So worms in gardens are good. Many plants thrive in ecosystems with worms, terrestrial worms in the ground, or marine worms in the water. Like they're a good food source. They're part of the cycle that keeps everything growing good. But the most recent glacial period in North America was the Wisconsin glacial episode. And if you look it up, it covered a lot of Canada and the upper Midwest of the United States and a lot of the Northeast, so like New England, and some of like Idaho, Montana, Washington. It stopped kind of like the Ohio and Mississippi rivers. So in the places that were covered by Wisconsin glaciation, where the ice sheet expanded out and then retreated, earthworms died out.
Oh.
There wasn't enough plant growth and nutrients. There wasn't enough like moistness. There wasn't enough food. So earthworms around 75,000 to 11,000 years ago died out in that part of North America. And that thus came the problem with invasive earthworms. So without earthworms there, the forests, particularly the deciduous hardwoods in upper North America, got used to growing without an abundance of decomposers. And they got used to layers and layers of leaves and different nutrients layering up. And through adaptive evolution, like through the chance and plants surviving, they started having root systems that took advantage of nutrients closer to the surface, these nutrients that pile up over time rather than being incorporated deeper, unaerated soil, like more compacted soil, and even things like seeds just drifting to the surface and kind of getting buried in the leaf litter, and other animals that like camouflage in the leaf litter and whatnot. And so there have been several rounds of invasive earthworms, and they just change the nutrient composition. It's not necessarily like a black and white good or evil, but it's increasing the availability of some nutrients that the plants aren't used to having at shallow depths, and eroding this organic material, this like thick layer that is used to building up. They're eating seeds that are normally just scattered across the top of the forest and pooping them out deeper so the plants can't grow. Like it's changing the types of plants that can grow. And so a lot of these old growth forests are getting stressed out with invasive earthworms because it's just changing how nutrients are being cycled around and what are available to these plants that have evolved over thousands and thousands of years. All of a sudden, they're like, whoa, this is different than what I'm used to. And it's not in an intentional way like agriculture where humans are like studying the plants and what they need and then adding bits and pieces. It's just like worms are here doing their worm thing and the plants are suddenly having to adapt.
Here's how I'm feeling a little bit. Correct me if I'm being awful.
Yeah.
We're not going to fix this problem.
Doesn't seem like it. Yeah. Seems like the worms are there and it's hard.
Yeah,
you can't be
like we're not going to like dig out all the worms and be like, we're going to make a worm-free land. It sounds like they're stressing out these forests. It doesn't sound like they're like destroying the forests. It sounds a little bit like somebody kind of wants to write an article about how earthworms are bad because that's counterintuitive. Like earthworms are bad for the environment. You're like, I kind of want to click on that because that's not sort of what I've heard. And like, yes, but there's nothing you can do about it. And also they are good for your garden. And also it seems a little bit like earthworms, it did exist in various places in North America. They just hadn't like recolonized that area yet.
Yeah. And I think the problem is they were introduced by humans on a time scale that is so short in the grand scheme of evolutionary time that it's a shock to the system.
Yeah. If you want to ask the Science Couch your question, you can follow us on Twitter at SciShow Tangents, where we'll tweet out topics for upcoming episodes every week, or join the SciShow Tangents Patreon and ask us on Discord. Thank you to @VitaBjornen, @Raccoon Required, and everybody else who asked us your questions for this episode. If you like this show and you want to help us out, super easy to do that. First, you can go to patreon.com/SciShow Tangents to become a patron and get access to things like our newsletters and our bonus episodes. Second, you can leave us a review wherever you listen. That's helpful, and it helps us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just
tell people about us.
Thanks for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is created by all of us and produced by Sam Schultz, who edits a lot of these episodes along with Seth Glicksman. Our story editor is Alex Billo. Our social media organizer is Paola Garcia Prieto. Our editorial assistants are Deboki Chakravarti and Emma Dowster. Our sound design is by Joseph Tuna Medish. Our executive producers are Caitlin Hoffmeister and me, Hank Green, and we couldn't make any of this without our patrons on Patreon. Thank you, and remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing. In 1972, in York, England, we unearthed a fossilized human poop that's about 19.5 centimeters or 8 inches long, making it the biggest human coprolite found so far.
It's quite a turd.
Yeah, it dates back to around 800 CE, so it most likely came from a Viking's butt. And inside this poop rock, researchers found eggs from 2 kinds of parasitic nematodes, Acerus lumbricoides, also called a roundworm, and Trichuris trichuria, also called a whipworm. And these worms live in human intestines and cause problems like stomach aches and diarrhea. So who knows what factors led to this Viking getting constipated enough to poop out a huge solid log instead of diarrhea mush. But we can be thankful it happened so that we could learn that our ancestors had parasitic worms.
He was on vacation. That's what it was. Welcome to SciShow Tangents, the likely competitive knowledge showcase starring some of those geniuses that make the YouTube series SciShow happen. This week, joining me, as always, are Stefan Chin.
Hello there.
It's been a while since we recorded, so I actually haven't seen you in a while. How have things been going?
Nothing's new. I'm still moving in very slowly. Like, take one thing out of the box each day.
We're also joined by Sam Schultz.
Hello.
Who's got very blue hands right now.
That was going to be my tagline. No, I don't have it.
Oh, I didn't ask Stefan what his tagline was.
Oh, channeling that big Zamboni energy.
Ooh, I don't like it.
Yeah.
Sam, sorry.
That's okay.
Let's start all over again. Hi, Sam.
Hi, Hank.
So tell me about your tagline then.
Very natural intro.
We're going to leave the first one in.
Oh, okay. My tagline is currently covered in blue paint for a secret reason.
We've also got Sari Riley.
Hello.
Hello. How many?
I'm waiting for a prompt and a question to answer.
Sari, what is your tagline?
Yikes.
Just several yikes or just one?
Oh, just one yike.
And I'm Hank Green, and my tagline is all new skin.
Our worst intro yet.
I think it was tight as a mofo right there. That was really together. Every week here on SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts. We're playing for glory and also playing for Hank Bucks. I've had several people reach out on Twitter and they say to me, you should probably keep track of who's doing good in the Hank Bucks department.
Well,
so maybe we should do this.
Early on, there was a good reason not to.
Yeah.
Because we weren't doing them in order.
Now we are.
Now we can. I think it'll probably be totally fine.
Okay, let's do it.
We can figure out a way to do that.
Okay.
Yeah, I want people to be into the metagame of all of this.
I'm scared that it'll be like very skewed in some way and we won't realize it.
Mm-hmm.
Oh, skewed towards me.
Probably skewed towards Sam.
Yeah.
Since the show is called SciShow Tangents, you might expect that we go off on some of those, but we try to stay on topic. And if we go off on a tangent, if it is deemed to be unworthy, the rest of the team can force you to give up a Hank Buck for your bad tangent. Mm-hmm. Now, as always, we introduce this week's topic with the traditional science poem this week from Sari Riley.
There are plants shaped like pitchers with fluid within, and digestive enzymes to break down what has been unlucky enough to fall into these traps, except for one species. It's perfect for naps. Its mammalian tenants get sleepy by day, need a safe haven to roost and keep predators away. Whether they're flying solo or a mom-baby pair, cute woolly bats snuggle in and take care. Now you might ask, what's the plant get from it? Well, the bats pay their dues, and their currency is shit. Nitrogen-rich bat guano is a precious treat for a plant starved by poor soil that just wants to eat. So a bat and its toilet, what a friendship, what a team. And bat poop, I guess, is worth more than it seems.
This week's topic is bats, not poop. Not pitcher plants.
I know.
It could be a lot of different things.
Mutualistic
not mutualistic relationships, but just generally bats. That's a good bat fact that you turned into a very good poem.
Very good.
Usually, Sari defines our topic for us. Do you have what is a bat? What is a bat?
What is a bat?
Are they all related to each other, or are did they ever convergently evolve? I don't actually know the answer to that question.
They're all related to each other, as far as I know.
Yeah, I think that is the case.
In an order called Chiroptera.
Do you know what their clade is?
I don't.
Because I know what their clade is.
What's a clade?
A clade is a taxonomical subcategory.
Okay.
Basically. I think it's a category within another taxonomical category, but there's lots of different kinds of clades. But they are in the clade Scrotifera, which is mammals with scrotums. Though we are not in Scrotifera, which is a little confusing.
Why not? Is ours different?
Ours is different. I think that our scrotums evolved separately from bat scrotums. Okay. But I'm not sure. I just know that we're not in Scrotifera and bats are.
So all Scrotifera evolved from one ancient scrotum.
Correct. I mean, interesting. Yeah, really? I mean, they definitely came from the genes contained in one ancient scrotum.
Oh,
yes.
That's beautiful.
It's beautiful.
There's something poetic about it.
But sorry, I interrupted because I wanted to talk about scrotums. Does anybody want to charge me for that?
I don't think so.
I liked it.
Yeah.
Okay. Yeah. Bats have scrotums, part of the definition of a bat. They also have, they're the only mammal that actually flies. So there are other mammals that can glide. They have membranes between their limbs, but bats have modified arms, essentially, that they can flap and fly through the air and don't just soar down like a flying squirrel or a colugo or something like that.
And all bats have a common bat ancestor.
As far as I know, yes.
Yeah. Papa Scrote, I think they called him.
And then they're the second largest order of mammals, which I thought was interesting, like by number of species that they have.
Wait, second largest?
Yeah.
I thought they were the largest.
Yeah, I thought so too.
Rodents, yeah.
Oh, rodentia.
Like you're learning something.
You're learning from the show.
Yeah.
Right.
And some of them eat insects or fruit. Like those are the two main categories of bat food.
And blood.
And blood.
What about the drinking blood?
Yeah, then they're vampire bats who are off in their own corner.
And they gave all other bats a really bad name, basically, right?
I think also bats carry a lot of diseases, and especially like viruses and stuff that are transmissible to humans, which probably helped spread the vampire myth.
Okay, so we know what bats are.
Yes.
They're cute, too. I think they're really cute.
Yeah, Sam defined bats.
They're cute. I already did.
They're fuzzy, cute fly balls.
Are even the big ones cute? Like the 2 to 3 meter wingspans?
Like a flying fox?
Yeah.
Yeah, I would be friends with a flying fox.
And now it is time for... One of our panelists has prepared 3 science facts for our education and enjoyment. One science fact.
Hopefully you've listened to previous episodes and know how this segment works already.
So there's 2 fake facts, 1 true fact, and the other panelists have to figure out either by luck or wild guess which is the true fact. If we do, we get a Hank buck. If we don't, then Stefan gets that Hank buck.
Give me it.
Stefan, what are your bat facts?
Fact number 1. The lesser short-tailed bat is the only species of bat that we know of that has evolved flightlessness. It lives in New Zealand and crawls around on all 4s, foraging for food, and chews into trees to create little burrows for itself.
Flightless bat! If that's not real, I'm gonna give you a Hank buck anyway.
Ooh, I'll take it. Fact number 2. While the vast majority of bats are nocturnal, the Samoan flying fox is the only bat that exhibits, quote, strong diurnal proclivities, meaning that they are active and forage during the daytime.
Okay.
And number 3,
weird.
While most bats grab onto things with their feet and roost upside down, the bats in the genus Thyroptera are one of 2 bat genera that roost head up, but it's the only one that uses suction from little cups on its hands and feet to hang onto leaves so it can do that.
That's cute.
So we've got flightless bats that burrow into trees, the daytime bat, and suction bat that roosts head up.
Oh, man. There are so many different kinds of bats. So, any of these seem totally plausible. I am a big fan of the flightless bat, though, because I would never have thought of a flightless bat existing. But Like it totally could. It makes sense. Would you say it was from New Zealand or something? Where there's also lots of flightless birds down there.
The diurnal bat seems the fakest to me.
Because it feels like there'd be lots of diurnal bats.
Yeah. Because like not all bats are nocturnal, I think, which like by definition means that some of them have to be diurnal. Also, not all bats eat insects. So like there are bats that eat fruit and you don't need to look for fruit at night necessarily.
Right. So are bats mostly nocturnal because that's when the bugs are out?
I don't know.
Why? Because it's not like they need to worry about predators too much, except for like, I guess, birds of prey.
Mm-hmm.
Because it's going to be hard to catch a bat. I am going to go for the lesser short-tailed bat, the bat that does not fly, a flightless bat.
I'm going to do suction cup bat also because I love it.
I pick suction cup bat too.
Okay.
It was the suction cup bat. So the Samoan flying fox is mostly diurnal, and there are a few species that we know of that fly around during the day, but there's only like four species total, and they all live on islands where there are not predatory birds. I think the leading hypothesis for why bats became nocturnal in the first place is that when they were first evolving, they had to compete with predatory like hawks and owls and things.
Who are probably way, way, way better at flying than they are.
Yeah. Right. Okay. And I typed in flightless bat into Google and I got the New Zealand lesser short-tailed bat. But it's not flightless.
It's not flightless.
It just crawls around a lot.
Yes.
It's just lazy.
Yeah. No, I don't know why it does it, but that and the common vampire bat both spend a lot of their time on all fours, like
walking around.
Lazy makes sense to me for that because it probably
like
takes a lot of energy to fly.
Yeah, but you go much faster than when you're just walking around with your big wings.
Yeah.
And it's like harder to run around when you have wing arms. Like,
yeah, like your hands are just giant.
Yeah,
You're
flaps
walking on
of
like
skin.
your
walking
tops of
on
your
your
hands
knuckles
or something.
Yeah, just like one knuckle, right? Because their wings are their digits
Fingers.
spread out.
Yeah.
So.
But yeah, so those bats still fly. The New Zealand one does actually chew into trees to make little burrows for itself, whereas most bats roost.
Right.
And these ones actually roost most of the time. Just sometimes they chew into a tree. So then the true thing was about the suction cups. And there are two genuses, Thyroptera, which are the disc-winged bats, but they use suction to stick onto leaves. And the other genus, Mysopoda, are called sucker-footed bats, but they don't use suction. They secrete a sticky, wet fluid from their pads.
Cool.
They just like have stuff that leaks out of their fingers. Yeah. I'm glad that's not me.
Yeah. Well, you could climb stuff though.
But like touching things.
Yeah, that would be a struggle.
Typing would be hard.
We'd all
Just
have to wear
gloves. Yeah.
And then you take your glove off at the end of the day and be like, look at all my goop that has been accumulating inside of my glove.
You know, when you go to the bathroom, you change your glove.
Right. I like this. I like this speculative universe in which everybody has to change gloves every 30 minutes.
Everyone just has
because
really
we evolved from sticky people. All right. Next up is the fact off. But first, a word from our sponsors. Now get ready for the fact off. Two panelists bring science facts. That was a big one. Bring science facts to present to the others in an attempt to blow their minds. The presentees each have a Hank Buck to award the fact they like the most. So you award it to the one who blew your mind the most. It's gonna be me because it's me versus Sam. I'm not saying that Sam.
What?
Whoa! Doesn't. I'm just saying it's gonna be me. I want.
Now I'm biased.
I heard what you said.
You don't have the Dracula voice either to like make it funny.
It's me against Sam.
Oh, I wouldn't stand a chance against Dracula.
It's me against Sam, and I'm sure that we have equal chances of winning. The person who's gonna go first is the one who most recently gave blood. When was the last time? It's been a long time. It's been a long time for me too. I give blood to my doctor like once every. In fact, I'm scheduled to do it today, and I didn't, but I should have.
But this
regularly.
is like to the
this is to
bank.
this is to the people who need it, the vampires.
Yeah, I think I was in high school. Maybe.
Oh,
It's
okay.
been a long time.
Oh, all right. Well, it was definitely me then. I got the good blood. I got the universal donor blood, so I feel bad not doing it.
Yeah, it makes sense.
So I probably gave blood last like 2-3 years ago.
I I have B positive, which is a nice little reminder for me.
I do too. And my dad would always make jokes about it because I'm like not a super optimistic person all the time. And he'd just be like, be positive, Sari. Just
and
very
like,
weird.
Go to
yeah.
your room, Dad.
Yeah, I'm being an angsty teen right now.
I don't need that.
Mm-hmm.
All right. So I guess that means I go first. Everybody, you know about dolphins, right?
Uh-huh.
Yep.
They are like bats in one way, but almost no other ways. We talked a little bit about how bats are in scrotifera, but it turns out dolphins are also, weirdly enough, in scrotifera.
Whoa.
What a stupid group.
Though they don't have scrotums, but their ancestors do.
They used to have a scrotum.
Yeah.
They look so funny.
Were they external?
Yeah, yeah. Their ancestors were like cows and stuff, like horses, and I don't
Did
know,
they just get
stuff
bitten
like
off
that.
one generation? And then
No,
that got
it
passed
wasn't
on?
good for swimming.
We need to do an episode about evolution, apparently.
We did one. I know.
Yeah, camels, pigs, ruminants, and whales are all sort of like together.
Cool.
And so those things have scrotums, but the dolphins, that would be really uncomfortable if they're just hanging out, flopping in the.
Yeah.
Anyway,
It's like a rudder.
that's not what my fact is about.
Good. It's not real.
So they are somewhat closely related. Like they're more closely related to each other than they are to us, for example.
Mm-hmm.
But they are very different things. Like it's a tiny fuzzy thing that flies in the air versus a big, not fuzzy thing that swims in the oceans, and mostly just the oceans. But they do have this thing in common where they both echolocate. They see with sounds, and they do it very efficiently and effectively. And this is a thing that evolved. And it evolved from two animals that evolved it independently of each other. But since they're fairly closely related animals, it turns out they evolved this in exactly the same biochemical way. Mm-hmm. So usually convergent evolution is a thing that happens when a bat and a bird both have wings, but they got their wings in totally separate ways. Like a bird's wing is the whole arm, a bat's wing is just the fingers, is just a separate thing. Mm-hmm. But in this case, the same protein, prestin, in the ear has the same mutations in it that makes it different from our prestin in dolphins as it does in bats. They have the same different genes, but they evolved those different genes entirely separately. It's one of the best cases of convergent molecular evolution there is, and it was only recently discovered, and I find it very cool.
That is very cool.
What does the gene specifically do? Does it just
It codes for a little hair in your ear.
Okay.
That hears better. Mm-hmm. Basically, it's a change that lets them hear more sensitively.
That's interesting to me because dolphins also don't have big ears to channel the sound in.
Right. Yeah.
So the fact that they have the same mutation and that functions underwater and above water and without ear flaps.
The ear area.
Yeah.
Well, I assume dolphins have ears, but do they open to the outside world? Because I know there's whales that have internal ears. I think it's whales, but then sound just transmitted through their jaw. There's a material in their jaw,
a bone or
that
something
can transmit the sound to their ear canal.
Dolphins do have a tiny, tiny little ear hole.
Okay.
It is pretty much invisible unless you're looking for it.
But that is where the sound goes back in.
Yeah. And that's where their prestin
little hairs are.
There are 14 points of mutation that they share with bats, and they all changed in exactly the same way. Whenever my son walks into a place that echoes, it sounds different because it's got some reverb quality. He goes bop, 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 and I'm like, you are echolocating, aren't you?
Maybe he's got the little ear hairs.
It's super cute. We walk into a tunnel and he's like, bop, bop.
He's gonna catch some bugs.
Yeah. So that's my fact.
Good.
Hit me, Sam.
All right. So bats echolocate to find food.
Yeah.
I think. All right.
Bugs.
And one thing that they eat, moths. And this is a conjecture on my part, but the moth seems like a pretty good food for a bat because they're big and they don't seem like they fly so great. Yeah. And they're very easily confused by lots of stuff, including light. So they can just swoop around and eat them. But there are some types of moths who have learned to fight back against bats. So there's a family of moths called the tiger moth family, and they make clicking sounds by vibrating membranes inside of them.
Oh.
Scientists have known about this for a long time, and that a lot of tiger moths are poisonous, and so they click to alert bats not to eat them because they are poisonous. But there's a type of tiger moth called the Bertholdia trigona, which has way louder clicks and isn't poisonous, and nobody could figure out why until 2009. So in 2009, they tied a bunch of moths to the ceiling with like fishing line, I think, and they were just dangling down, and they let bats out into this room to eat the moths, and some of the moths could make the sound, and some of them had been altered so that they could not click. What they discovered,
in a very humane way.
yeah, probably not just with a big needle poked through them. So what they found was that the bats caught the non-clicking moths 400% more often than they caught the clicking moths. And the ones trying to catch clicking moths, the bats trying to catch clicking moths, looked confused and hesitant to try to catch the moth. So what they determined after taking a closer look was that the moths could make 4,500 clicks per second, which basically made like a curtain of sound that the bats got like garbled feedback from their echolocation.
Jammed the radar.
Yeah, totally. So they couldn't tell where the moth was, so they would like swoop into like thin air and not be able to grab the moth. That's it.
That's amazing. So cool. I love that.
Wow.
Oh, I thought I was a shoo-in, but now I'm not so sure. We did a SciShow on various moth strategies for not getting eaten by bats, and it's also potentially why they're fuzzy. It's because it, like the echolocation bounces back less
it's sound
efficiently.
Foam.
Yeah.
Cool.
It's sound foam for moths.
Whoa, so moths have just devoted their lives to not being eaten by bats.
Which is probably a pretty good strategy for a slow-moving, juicy bit of food that lives in the air.
How do they make the clicks? Like, do you know anything about the organ that does that?
I couldn't find anything that described it super. It just said membranes inside of them.
Oh, okay.
So
that makes sense.
Clicky membrane.
Yeah.
Membrane.
And so the poisonous ones make a lot softer clicks that the bats avoid.
Right.
But the louder ones, the bats don't avoid. So that's why they were like, what's going on here?
I mean, my thought would be like, they're just trying to pretend like I'm also clicky.
Yeah.
I'm poisonous like a mimic.
Mm-hmm. And there are non-poisonous ones that do that too.
Oh, okay.
These ones just like, they're so loud you can hear them without any kind of like special equipment. You can just hear them flying around in fields.
All right. Those were two very good facts. I have no idea what I would choose, but me, though.
I'm going to give mine to Sam because that was more mind-blowing to me. Just like learning about the curtain, the sound
really
curtain.
Good. It is. They're jamming the radar,
visual.
but convergent molecular evolution.
I know.
14 points of each.
Do love a good probability.
Yeah.
Well, mine's that probability too, right?
Sam's is less mind-blowing from a statistical standpoint, but the mechanism is more mind-blowing.
Membranes.
So I'm going to give it to Sam.
No!
I was very satisfyingly mind-blown by both.
Okay.
Mm-hmm.
Yeah.
Yes.
But I got more points.
Now,
You're banished.
I will survive. It is now time to Ask the Science Couch, where we ask listener questions to our couch of finely honed scientific minds.
At Gannon188 and at BiologyAlex ask, is there any cure for the fungus, aka white nose syndrome, that's wiping out the United States Northeast population of bat?
You're looking at me like I have any idea.
I have never.
I got nothing.
Have you heard of white nose syndrome before?
Yeah, it's definitely a problem. And like the question has been, in my understanding, is this just a really bad pathogen, or is there some human cause that is making it worse, like pesticides or habitat loss or something that is making it more common for it to be spread more easily? And I don't know the answer to that.
I saw a picture and it looks a lot like moldy nose.
Yeah, it's like you get a fungus face.
Is fungus and mold, are those the same thing?
Yeah,
Okay.
mold is a fungus.
So yeah, it is a fungus. I don't know if we're confused about how or why it spreads, but it started in winter 2006 in Albany, New York. As far as we know, it was probably other places too, but that was the first documented case of it, where they found dead bats with white fuzz around their nose. It's a fungus called, oh gosh, I couldn't find a pronunciation, so this is just me doing my best with my biology knowledge. Pseudogymnoascus destructans.
Ooh,
That's a bad name.
Yeah.
I
They're
don't want that.
This one bad. And it attacks the skin of bats. So that's why it shows up around their nose, because that's not where they're as fuzzy, but it also attacks like their wing tissue, anywhere that is exposed skin. And essentially what it does is like this attack on their immune system makes them wake up when they should be hibernating. So during the winter times, during the daytimes, and use their fat reserves when like they should be conserving energy. So it destroys their tissue and then leads to really malnourished looking bats. Really, their wings like tighten up for some reason. I think because like the whatever makes it flexible maybe gets destroyed. I watched a video and like a woman was pulling on a bat wing, which would normally stay extended, and it like contracted really quickly.
Why does it wake them up? Because they're in pain or something, or just messes them up?
I think so. I think it like messes up something with their internal systems. I don't know exactly how it attacks them, but it's like a bad infection. It'd be like getting a bad cold, but fungus in your body, I guess, which is not the same as a cold. One source that I was reading called it one of the worst wildlife diseases in North America. So since winter 2006, it's killed over 6.7 million bats by some estimates, which is a lot.
Yeah.
And it can kill 70 to 90% of bats in an infected, I love this word, hibernaculum, which is the place where bats gather to all hibernate in a group.
Oh, yeah, nice.
So like it's a hibernaculum of bats.
Where do they hibernaculate?
Caves, probably. You know, your general bat places.
Okay, they don't have a special place.
A lot of caves, yeah. And this is, you can see maps of where this is found. It's mostly in the Northeast U.S., mostly in Canada, like that general region, and they're finding it more and more western in the United States. And we've actually found this fungus infecting bats in other countries, so like several other European countries, and I think in China. But in the U.S., it's extremely deadly for some reason. And we think it was transported over here by humans, not by bats, because there's no way for a bat to migrate across the ocean in that way. So it was probably like a human in a cave, got the fungus on them, spread it to a different cave. And just like the colonizers, we have infected the bat population and are now decimating them. So that is white nose syndrome. We're trying to figure out possible cures for it. And a lot of the research that I found is pretty like the beginning stages of it and pretty recent. So one main avenue is like people studying the DNA of this fungus. And they found that one, it needs cold to grow. Like something about its genetic makeup makes it require cold.
So we should heat the earth up.
Oh, perfect.
We warm the planet, global.
How would we do that? Good idea, but I need some avenues.
At least the bats are going to be.
So they're not entirely sure what to do with that information, but also during the same genetic research where they discovered that it needs cold to grow, they also found that it's missing the repair mechanisms for DNA when it's damaged by UV light. So, I don't know, in all of our bodies, we have a bunch of cellular molecular biology mechanisms that like our DNA is constantly being damaged by UV light, having mutations, and then it goes back and fixes it. And so this fungus doesn't have it. So
we need to shine the light on the bats.
Yeah, they're trying to figure out a way. I think they called it a UV tunnel or something, like constructing those at the entrance to caves.
They have to like crawl through the UV light.
Yeah, or like they fly through it and get blasted by UV light, which doesn't harm the bats because they have the repair mechanism, but the fungus doesn't. But it sounds extremely elaborate. Like you need a lot of timing. And
that would be good for maybe one cave at a time. They
also found that there is a fungal compound that inhibits the growth of P. destructans. They had, I'm guessing, like dishes of P. destructans and then sprayed this mushroom vapor on them.
Vaping that truffle butter.
So our solutions are global warming, just UV tunnels, and the bats have to vape.
Yes.
Sounds great for the bats.
Yeah, they can like tan and vape.
Very cool. And one professor has tested bat vapes, but he called it a bat fogger instead.
What a loser.
I think he used some sort of antifungal volatile organic compound, which is what this mushroom alcohol falls into. So some sort of chemical. I'm not sure if it was this exact one, and sprayed a bunch of fog into an abandoned railway tunnel where bats roost. And the numbers were higher than they expected. Like this was a colony that they'd known was infected with white nose syndrome.
Mm-hmm.
It had been decimated in years past, and it was like slightly higher than they expected it to be. So maybe it helped. We're not sure.
But it doesn't seem to be something that's going away on its own. Like I haven't heard as much about white nose syndrome as I did like in 2011, I feel like. But that's just because we got tired of talking about it, not because the problem's gone away.
So the people who are studying these bats and studying white nose syndrome have also just been tracking numbers of like population numbers to see what is happening and where they have to concentrate their efforts. And it seems like certain colonies are rebounding by themselves. So like to give you a sense of the scale, one that they were monitoring had about 90 adult bats in 2010. And then in 2018, when the article I'm reading is published, it rebounded to 200. And they're not entirely sure why. Like, is some sort of natural selection happening where maybe bats that are more resistant to the fungus and this disease are surviving and passing on the genes that help them? Or is it behavioral avoidance of sick bats? Like, are they learning some sort of behavioral trait? Are they, I don't know, is the
just
fungus
going to lay out in the sun?
Yeah.
In the daytime, just being like, what if we just like put a UV light in the cave and be like, if you guys want to use this, you can.
Just imagine leaving little presents in each of the bat cave. It's like a little UV lamp, a little vape pen. Here you go. Take care of
Space
yourselves.
heater.
Yeah, space heater. Do with it what you will.
Yeah.
So it is like a very intense, very devastating thing, and people are worried about the bats. And it like sucks that it was probably human caused.
Right.
And so humans want to try and fix it, but epidemics happen in nature all the time, and species adapt or bounce back or
don't
go extinct locally.
No.
Yeah.
So something's gonna happen.
Oh no! I'll go shine lights on bats. I'll do it.
Sam's got a new job.
Gonna
He
go to every
quits.
cave. Yeah.
If you want to ask the Science Couch, you can do that by following us on Twitter at SciShow Tangents, where we will tweet out the topics for each episode every week. All right, so it looks as if I lost. Sarah, you've got 2 points. Thank you.
Oh, that's not a winning? Oh no.
It's not. Stefan, you've got 1 point. Sam.
Yeah.
Pulling out the win with 3 Hank Bobs.
How?
I should have thought about this.
Oh, I know how.
Yeah.
1 plus 2.
Sam, I don't trust you to tally up all our scores now.
You better build a spreadsheet so I can check your math. All right, if you like this show and you want to help us out, it is super easy to do that. You can leave us a review wherever you listen. That's going to help us know what you like about the show, and also other people will know that too. Second, you can tweet out your favorite moment from this episode. I love it when I see those. And finally, if you want to show your love for SciShow Tangents, tell people about us. Thank you for joining us today. I have been Hank Green.
I've been Sarah Riley.
I've been Stefan Chin.
And I've been Sam Schultz.
SciShow Tangents is a co-production of Complexly and WNYC Studios. It's produced by all of us and Caitlin Hoffmeister. Our art is by Hiroka Matsushima, and our sound design is by Joseph Tuna Medish. Our social media organizer is Victoria Bongiorno, and we couldn't make any of this stuff happen without our patrons on Patreon. Thank you. And remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing.
Is it about bat poop?
It is about bat poop. All my facts are about bat poop.
They got good poop.
They got great poop. Bat guano has a really high nitrogen content, specifically compounds called nitrates, which, if you put them through a couple synthesis process, can be turned into things like fertilizer, but also gunpowder. And so at times, like this particular one is a Civil War, when supply chains were cut off to the Confederacy, they would go to bat caves, mine a bunch of bat poop, put them in kilns, and create gunpowder from poop.
Wow. So we killed each other with bat poop.
Yeah.
Leave it to humans.
Yeah, it's the
Everything is
ingenuity of
chemicals,
a
yeah.
bloodthirsty human being.
Welcome to the SciShow Tangents, the lightly competitive knowledge showcase starring some of the geniuses that make the YouTube series SciShow happen. This week, as always, I'm joined by Stefan Chin. good. Hey. Stefan, what was your first email address?
I don't want to say. It's my current email address. But my first instant messenger, my AIM name, was Joseph2G. Because a girl that I liked called me Joseph.
You were like, all right, I'm Joseph now. It happened. Everybody. Melinda says, I'm Joseph. What's your tagline?
It's a gosh darn lovely day.
Oh, Sam Schultz is here as well. What's your tagline, Sam?
Spider anxiety.
Sari Riley has joined us today. How many Earths would it fit inside of the sun?
Oh. Okay, I'm going to guess, and then you laugh if I'm way off. 350.
Oh, that
seems low.
Yeah, you way off.
Oh. I don't know how big things are.
Yeah, it's over 1 million.
Oh, whoa. That's a lot. I feel like once things get a certain amount of big, I am not good at understanding how big they are relative to each other. I know that's like a human problem, but me especially, even with like crowds above 50 people, like, I don't know, that could be 100 or 300.
What's your tagline, Sari?
Egg apocalypse.
And I'm Hank Green, and my popsicle is Taco Burp. Every week here at SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts. We're playing for glory, but we're also keeping score and awarding Sam bucks from week to week. We do everything we can to stay on topic, but we're not always going to be good at that, so if the rest of the team deems your tangent unworthy, we'll force you to give up one of your Sam bucks. So tangent with care! Now, as always, we introduce this week's topic with the traditional science poem, this week from Sam.
This poem was already read by me in the unreleased pilot episode, so this is kind of a behind-the-scene peek for everybody. And not due to my complete mess of a life. My dad always says, when he was a kid, there were frogs all over. You'd hear them all night, sitting by the stream, doing whatever frogs do. In the time I've been around, I've seen a couple frogs, swimming somewhere maybe. I don't really remember. I think I probably know where they all went, but I won't go into it here. I know some other frogs, like Kermit or the Budweiser frogs, and they are good frogs, but there used to be more. The end.
It's very different. It's a very different vibe from our current Tangents poems.
Very free
that was the very first Tangents poem ever written.
Yeah.
Oh, really?
Yeah. They're a little happier now, usually.
Yeah. That was just kind of like a collection of thoughts that you think at 2 a.m. about frogs.
So the topic today is frogs. Sari, what's a frog?
We actually have
my favorite part of the podcast is when I get to say that. Sari, what's wind? Sari, what's the sky? And I'm just like, I'm going to sit back and get learned on.
So we actually have a definition for frogs, which are exciting. They're amphibians in the order Anura. So there's a whole order of them in the class Amphibia. And basically, they are very diverse, but they're pretty stout, tailless amphibians. And they're widely distributed across the planet from the tropics to subarctic regions. And toads are frogs. So toads are the family Bufonidae, or Bufonidae, which is a subcategory of the order Anura. All toads are frogs. Not all frogs are toads.
I am a little surprised that you included the word stout in your official definition of a frog, because to me, stout is a completely subjective thing. But then I look at a frog and I'm like, yeah, compared to like other reptiles, which are very long, they're kind of stout.
Yeah, they're not very long. They're not very tall. So the only adjective to describe them is stout.
A stout. Yeah, okay.
Are you looking up the definition of stout?
Yeah, I've never quite locked on to what stout means.
No, it means whatever a little teapot is.
Yeah,
stout.
Teapot.
Yeah.
Winnie the Pooh is stout in my brain.
Winnie the Pooh is definitely stout, yeah.
Sari, do you know the etymology of frog, which is a great word?
It is a great word, and it's even better because it's mysterious. Like,
Ooh.
I can't find a good etymology for frog. The Proto-Indo-European root is preu, P-R-E-U, to hop, and then it just jumps to frog, or Old Norse frosker, or Old English frogga. And so at some point, we switched from jump to frog, and who knows? A linguist somewhere, maybe. But then, like, rana is the Latin word for it, which is sort of like croaking. And then bufo is toad from Latin, but like, I don't know. They're all, it's like from hopping or slimy, or I don't have an answer.
What else are you going to call them though, really? They are frogs.
Yeah.
So it's basically like calling something like jumper, which that's what I'd call it if I didn't know what it was called. Well, thank you, Sari Riley in Dictionary Corner. Now it is time for one of our panelists, and it's Sari, has brought 3 science facts for our education and enjoyment, but only one of those facts is real. The rest of us have to figure out which is the true one, either by deduction or a wild guess. And if you get it right, you get a sandbuck. If not, then Sari gets the sandbuck. And remember, you can play at home at twitter.com/SciShow tangents. So Sari, what are your 3 facts?
So, part of what's so weird and incredible about many frog species is the drastic change from a baby tadpole to an adult frog, which is sort of like what we were talking about with tails. So, which of these weird tadpoles is real?
Oh, weird tadpoles.
Yeah.
I didn't know there were many kinds of tadpoles.
There are. You're going to learn about them. So, number 1, after hatching, the tadpole of the species Notoden bennetti poops out a sticky super glue-like substance in a lump. Small phytoplankton or algae or things like that get stuck to that glue poop, and then the tadpole can just slurp it up to get food plus their nutrients back. And then they poop again, and the cycle repeats, so they can cautiously venture out for food, but always have a safety lump of glue poop stored up. Number 2, the tadpole of the species Microlaxis harryi are really muscular and flat. They have stiff ribs on their tummy and bulbous eyes covered in a layer of skin. So they sort of look like tiny buff eels instead of your typical tadpole. And that's because they don't swim around in water. They live in wet sand and need to be strong enough to burrow through the particles without getting hurt.
Ooh,
What?
weird. Okay, good.
Or number 3, the tadpole of the species Ascaphus montanus is sort of like a mini Hulk vampire. After they hatch, they have leech-like mouths and suction on to the nearest living thing, like a fish in many cases. They feed like a parasite, and they grow about 2 to 4 times larger than the adult frogs of that species, some even approaching a foot long. So these are really big babies, and when they metamorphose, they get smaller instead of bigger.
Oh, God.
What?
Oh, geez.
How big are they?
2 to 4 times larger than the adult frogs, some even approaching a foot long.
Ugh, I hate that.
But like the adult frogs are like 2 to 3 inches and then bigger than that. So it can vary from like 4 inches, but some of them have been found to be very big, beefy tadpoles.
Okay, so we've got a tadpole that poops out sticky super glue to catch food, a tadpole that looks like a buff eel and swims around in the sand instead of looking like a tadpole. So it looks like a buff eel. I want to Google it, but I can't because that would break the game. Or third, a tadpole that's like a mini Hulk vampire. These all got to be true. That all seems perfectly possible to me that there would be any of those things. I love secreting glues, but I know a number of organisms secrete glue, and so that's drawing me away from it.
I just think you wouldn't secrete it out your butt. You would accidentally super glue your butt shut.
That's a good point. And that does go poorly. That happens to baby chickens. It's called poopy butt. No, I don't know what it's called. But it is a real thing where they like pasty butt maybe. And they have to like clean their little butt so that they can poop.
Oh.
Huh.
I think you'd be immune to your own glue maybe though. Or is that not how glue works?
I mean, I think it could certainly be how glue works. Evolution has all kinds of tricks up its sleeve.
Okay.
But then you have to eat your own butt to eat the food. Is that how it works?
Yeah.
Well, animals don't mind eating their own butts though.
Okay. And that's their like primary / only way of eating?
Yeah, for the first few bit of life when they're just newly hatched.
So we got buff eels in the sand as well.
Yeah. This one freaks me out because you said they had ribs, and that's making me think about how bones work in a tadpole.
Do tadpoles have bones?
Are they just born like a skull and they grow more bones? Or do they not even have a skull? What's their deal?
I think they have basic bone structure. I know frogs have bones.
Right.
Yeah.
My guess is that tadpoles just have fewer.
Yeah. I mean, they're vertebrates, so they got to have a spine. And then probably they got to have something for their muscles to connect to.
Yeah. So ribs don't seem out of the question. But also, I've never heard of a tadpole that doesn't live in water.
Well, it could be like wet sand.
It's got to be wet sand. And then we've got the vampire tadpole, and my only problem with this is that, like, wouldn't somebody have told me if there was a vampire tadpole? I feel like that would have come up.
Are there other things that get bigger before they become an adult?
Oh yeah, bugs do this all the time, where their larvae are bigger than the eventual bug.
What the hell? I'm trying to find anything that will help me determine which of these is fake, and I have no idea.
Yeah, they're all very good. They all seem completely both plausible and also absolutely bizarre. I'm sure that every frog, go pick a frog. And this is what I did for my fact off fact. You pick a frog. There's something weird about that frog. Something really weird about it. All right, everybody, the moment has arrived. Go to twitter.com/SciShow tangents to vote. And now we will vote.
The butt glue seems so boring by comparison to the other two. So I think I'm going to go with that one, the butt glue one.
I'm going to go with the buff eel.
Well, I'll go. I don't know. I'm going to go with the buff eel too. I don't really have a reason.
Well, at least right. you're going to make me feel less lonely in our loss. Sari, is it the buff eel?
It is the buff eel.
Wow. It's the buff eel!
Yeah.
What luck!
Yes!
Yeah, I can't believe you both got it right. I was really proud of my lies.
They were both great, and you also had great backup, good information about them.
So they are all based off of real things, but to start with the real one, the buff eel tadpole, they just exist, which is very cool. So they are Indian dancing frogs. So India, the country. And they were named for the fact that they stick out their legs really long to do mating dances, which is very fun and cute. And so they're dancing frogs. So even though we discovered those frogs 125 years ago, as of 2016, I think, or 2014, no scientist had ever seen their tadpoles. And their tadpoles were the last to be discovered out of all known, I think, species of frogs and toads out there.
Wow. Were they just looking in the wrong place? Is that why?
They were looking in the water. Yeah, it's the only family out of the 54 frog and toad families that they hadn't seen tadpoles because they were always looking in the water. And then eventually, one group of scientists in 2014 to 2016-ish started digging in the sand because they were like, I don't know, we've looked everywhere else. And then they found a bunch of little wormy things that looked like tadpoles.
They're really gross.
That wriggled away from them and buried deeper into the sediment. And so they were like, it's the tadpoles. And so these are called fossorial tadpoles because they live underground instead of in water. And it is wet sand. And they do still breathe through their skin as far as I know. But they just eat the sand. So their intestines were full of sand and their outside is covered with a thick layer of skin so their eyeballs don't get scratched up by sand.
Ew.
And they just live their tadpole lives as though.
What do you mean they eat the sand? What are they eating? There's food in the sand?
Yeah, there's probably little crumbs of stuff in the sand, little tiny chunks of algae. And they're getting nutrients from it. But yeah, their entire digestive tracts were full of sand.
I love that there was a long period of time, and this would have been a good fact too, where you're just there's a frog that we don't know where it comes from. It's just mystery frog. Is there a vampire tadpole?
That is a mixture of two. There is not a vampire tadpole. There is a tadpole. It's the Rocky Mountain tailed frog, and their tadpoles have leech-like mouths, and they stick onto the bottom of rocks and in rushing streams and just stay there to be safe. And so when a researcher picked them up, they were like, it leached onto my hand. Is this really a tadpole? But that's just their adaptation to surviving in more fast-paced waters. They latch onto surfaces. And then there are paradox frogs, which do exist. They are frogs where the tadpole is way bigger than the frog, but the eggs are normal sized. So that's fine for the mother frogs. They don't have to lay humongo eggs to get the giant baby.
They just have to look at their ugly babies.
Yeah. Well, they leave them behind and the babies forage themselves.
Good.
So
That's good.
There is no super glue poop, but there is a frog called the crucifix frog, and it's really cute. It's really lumpy. It's my favorite kind of frog appearance, where they look kind of like a rock and look kind of sad and grumpy. It has evolved a sticky goo secretion from glands on its skin and back. They use it to attract insects to their skin, and then they just shed their entire skin and eat it. So very similar to this.
Holy shit!
Yeah. And they also use the glue to attach to their partner during mating. So, like, nothing slips and slides where it shouldn't.
I love it. Eat my own skin. All right. Next, we're going to take a short break, and then it'll be time for the Fact Off. Welcome back, everybody. Sambuck totals. It's a tie game. Everybody's got one.
Ooh.
That means that Stefan and I have the chance to run off with it here because it's time for the Fact Off. We have each brought science facts to present to the others in an attempt to blow their minds. Sari and Sam each have a Sambuck to award to the fact that you like the most, and to decide who's going to go first, we have a trivia question. Who's going to ask it to us?
Oh, I will. The average golden dart frog carries about 1 milligram of poison in its skin glands, which is enough to kill how many mice?
100 mice.
100 mice. Okay. Hank, how many mice?
500 mice.
Whoa.
Wow, you guys are not prepared for this. It is 10,000 mice.
Oh, holy crap.
Or 10 to 20 humans, or 2 African bull elephants.
Oh my God.
That is a toxic boy.
It seems like a little bit overkill, I suppose. But
How do I get, just like by what? Eating it or injecting it?
I imagine
Just looking
if
at
it's
it.
a tropical frog, it's touching it to your mucous membrane. So, like, getting it inside you somehow. When I was in
Okay.
Costa Rica doing some volunteer work, I convinced one of the guides to let me touch a poison dart frog. My teacher was not into it. The guide, very much so. And he was like, you can touch it, but once your hand starts feeling super tingly, you've got to wash your hands and don't touch your eyeballs or tongue or anything in between. Otherwise, you'll probably get poisoned. I loved it. I was in high school, and it was one of the most exciting experiences of my whole life.
I've suddenly started to feel bad that I employ Sari Riley, keeping her from her dream of being a frog scientist full time. I feel like we've discovered something. You're a big fan of frogs.
Yeah. I didn't know it. It's awakened something inside me.
did your hand feel really weird?
Yeah, it did. It started feeling like it was falling asleep a little bit. Like that kind of tingly.
Oh.
All right. Well, I guess I'll go first then. I want to tell you guys about this frog. It's called the Tungara frog. And different animals build all kinds of nests, and they're good for protecting their young animals. And you might turn to a hardy material like sticks or leaves, something that'll last a while and protect your young. Tungara frogs build nests, not out of either of those things. They're found throughout Central America, South America, and the Caribbean. And you might see their nests lining the edges of ponds or puddles or just bits of standing water. And so to make the nest, I have not described to you yet, the female Tungara frog will release her eggs along with a special fluid cocktail of protein and carbohydrates. The male frog will then whip that fluid into a foamy lather by stirring his legs around while also adding his sperm into the mix. And that spermy foam will keep the eggs hydrated and protect them from microbes and other potential environmental concerns. And if conditions are good, they will emerge from that foam 3 days later. But scientists have observed the foam nests lasting for 10 days. So if you can imagine like getting a cappuccino that the foam stays for 10 days, that's the situation we're looking at here. And this is actually pretty weird chemically. So scientists are very curious about it. There are ways to make foam that lasts this long, but the detergent molecules that we would do that would be small enough that they would get through the eggs or the sperm and damage the inside of them, which is the exact opposite of what you want this foam nest to do. So because they can't use that like what we would do, and we don't know any other way to do it, we had to study this and found that this all sort of hinges on one very unique protein inside of this protein carbohydrate mixture. So they studied all the components of the foam. It was mostly made up of 6 proteins that serve various antimicrobial and anti-insect defense purposes, which is pretty amazing. So 6 different proteins that do that. But one called RSN2 that provided that detergenty surfactant property to make the foam, but was too large to enter into and disrupt the membranes of the sperm and the eggs. So it might even actually also bind to those other proteins and carbohydrates to stabilize the bubbles and sort of like present out the antimicrobial, anti-insect parts. And then that just makes like a nice, beautiful microbless sperm foam for the frog's eggs to live inside of.
When the babies hatch, do they eat the foam? Is it like nutritional also, or is it just like they leave it behind?
I think they just leave it behind. I did not see any reference to them eating the foam, though. That would be great, because if your first act as a organism is just to eat the leavings of your parents' coitus.
Oh, boy. I hate it when you say it that
way. I really ruined Tuna on that one. Yeah. He's getting ready to not work here anymore.
Are they going to make like shampoo out of this frog foam? Is there something we can do with it?
Yeah, there is, though there weren't any published papers, but there's been a little bit of research on whether it would be a good like delivery mechanism for antimicrobial stuff. Mm-hmm. So to either use their antimicrobial things or to use ours, right, but sort of like use this weird surfactant protein to bind antimicrobial molecules to it so that you can like rub it on a wound. Also, the way that the males whip the foam up with their legs is pretty worth watching. So we'll put it up on SciShowTangents.org. They really whip it up. All right, Stefan, what do you got?
When you build robots, you're usually using synthetic materials. And so like if you make a bunch of nanobots and for some purpose to put them in the environment or in your body, because they're not super biocompatible, you can end up with side effects in the environment or side effects in your body. So this team took frog stem cells and built little bio robots out of them that are designed to perform different tasks. Like they could collect microplastics or other toxic substances, or you could use them in the body to clear plaque out of your arteries. And since they're just made out of cells, they're super biocompatible. And so they designed these robots using an evolutionary algorithm. So they like tell the algorithm, we're using pluripotent stem cells and cardiac stem cells. What you got? And these were cells from the African clawed frog. And then they program it with different desired behaviors. So I think all of them like can locomote in some way. Some of them are oriented more towards object manipulation, and some are oriented more towards object transportation. And so they got a bunch of these designs and took the most promising ones and then built them out of actual frog stem cells. And so to do that, they perform little microsurgery on the frog embryos to separate the cells out. And then in the video, it looks like they let the cells coalesce into like a sphere naturally. And then they perform surgery on the sphere to like sculpt it into the shape that the algorithm spit out. And then they layer in these cardiac cells in specific places, also according to the designs that are generated by the AI. And so then they have these little biobots, and there's no like nervous system or brain or anything like that, but the combination of the physical shape and the properties of the cells that they use cause these behaviors that they're looking for to just spontaneously emerge. And so
how big is this thing?
Pretty small. They're not that many cells.
Mm-hmm.
But it's enough to like one of them looks like kind of like a human tooth with 4 little legs.
Yeah.
And then there's a version that's like a tooth with only 2 legs.
Oh,
and there's some that look like Rubik's cubes, but if you poke out all the middle squares, so it has like holes and the center is hollowed out. And then all the like cardiac cells just naturally start contracting. And they said that they didn't select for this, but that they just sort of naturally like work together. And so it acts like a little muscle and like flexes the legs in just the right way to like get it to move. It's very weird. And if you cut them, they self-heal and maintain the shape of the design. And then there's sort of a built-in like lifespan timer because they eventually, like, they don't eat. So whatever like embryonic energy reserves they have is like whatever they have. And then once that runs out, they just die. And then they're just a bunch of cells that get reabsorbed or whatever into whatever, like, I guess if they were in your body. And so they imagine that you could use these to like trap microplastics or clean up other environmental pollutants, or you could have them transport medicine through the body to specific places or clear out plaque in the arteries, like I mentioned earlier. And they describe them as bespoke living systems, which I thought was kind of fun.
I like when, so they've got like the sort of 3-dimensional designed version that you can sort of see like, here's what we were doing. And then they've got the actual cell or the actual, not cell, but I don't know what to call this thing.
They call them biobots, but it's like, because it's not an organism, it's not alive.
Yeah,
but it's like living
so there's
cells.
these little biobots. When they're zoomed up in close on them, they do not look good. They look upsetting to me.
Why were frogs stem cells specifically good for this? Could it be any stem cell or?
I don't know if why frogs specifically, but it might just be that they know. Like they had a good enough idea of the properties of these frog stem cells that they could simulate it well. And so that the simulated designs, they could be confident that it would translate to the real world. But I'm not actually sure.
That's pretty cool, man. That's pretty cool. I don't know if it's a frog, but it's pretty cool.
It's parts of a frog.
That's not a frog.
But is it stout? Would you call these little things?
Yeah, those are definitely stout.
Definitely.
All right, so it's time to vote. Would you vote for the Tungara frog that creates a durable foam nest for their eggs, or a team of researchers that made little bio-robots from frog embryo stem cells that could be used to clean up the environment or in medicine?
I don't know.
This one's really hard.
Yeah, I agree with you. 3, 2, 1.
Stefan?
Fuck me.
Whoa. It blew my mind.
It like made my stomach actually queasy.
Yeah,
thinking about
it's too
frog
freaky.
cells. It's like this is the first step to Frankenstein's monsters,
Oh my
like fully
God.
reanimated cells that have no nervous system. They're just blobbing around, responding to stimuli. Ugh.
All right, that means it's time to ask the science couch. So we've got a listener question for our couch, digital virtual couch of finely honed scientific minds. It's from @KRSKJ1018. What makes the tongue of a frog sticky? And I'm going to go ahead and say the answer to this question is proteins.
Yeah.
That's kind of a cop out. That's what makes everything for the most part in animals. But yeah, that's as specific as I can get.
So it's a twofold combination. Frogs are wild. I love frogs.
Welcome to our new podcast, SciShow Frogs.
This is our frogcast. Hello, I'm your host. Frog tongues, weird. 2 things about them. One, they're really soft and squishy. They're like, these scientists created a machine to basically poke the frog tongue tissue and poke other tissues as well. And they found that frog tongues are about 10 times softer than human tongues and are also about as soft as human brains. So they're very, very squishy.
Oh, wow.
And
That's
that means
soft.
when it hits an insect, the tongue deforms. So a lot of contact is made with the insect's body because it's so soft. And then the second part of magic frog tongues is their saliva. And that's where proteins particularly come in. It is a 2-phase viscoelastic fluid. It like changes its thickness, like depending on the speed at which something is pulled and at the speed at which it's moving. And so when it hits an insect, the saliva is liquidy and seeps into cracks. And then when it pulls really fast, the force on it makes the saliva really, really sticky. And then it gets into the frog's mouth. And then without the extra movement, then the saliva becomes less sticky again so that the frog can blink and squeeze the insect down its throat.
That's genius.
Oh, I never thought about how it can actually swallow the stuff.
Yeah. If it's got to be really sticky, it's hard to get it off your tongue.
Yeah.
Unless you're just eating your own skin.
Yeah.
It's a separate mechanism.
Yeah, so it starts out thin and liquidy, and then as soon as it attaches on the insect and during that big yank, then it becomes really thick and gloopy, and then it becomes thin and liquidy again.
So does that mean it's non-Newtonian?
I think so.
Yeah.
Yes.
If it changes properties based on other properties.
Mm-hmm.
Yeah. Well, if you want to ask the Science Couch your question, you can follow us on Twitter at SciShow Tangents, where we will tweet out topics for upcoming episodes every week. Thank you to at Void6425, at Jameson D. Moore, and everybody else who tweeted us your questions for this episode. Sam Buck final scores. Sari and Hank and Sam all combined. If we were all working together, we would have tied with Stefan, who has 3 points to our 1.
Thank you.
Which means that Stefan is now in the lead.
Whoa! Chin bucks, let's go.
And I'm still, oh God, I'm not just behind. I'm dragging so far back there that it really does seem insurmountable at this point. If you like this show and you want to help us out, it's very easy to do that. You can leave us a review wherever you listen. Very helpful. Lets us know what you like about the show. Second, you can tweet out your favorite moment from the episode. And finally, if you want to show your love for SciShow Tangents, just tell people about us. And if you want to listen to SciShow Tangents ad-free, you could do that on Luminary. Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
I've been Stefan Chin.
And I've been Sam Schultz.
SciShow Tangents is a co-production of Complexly and the wonderful team at WNYC Studios. It's created by all of us and produced by Caitlin Hoffmeister and Sam Schultz, who edits a lot of these episodes along with Hiroko Matsushima. Our social media organizer is Paula Garcia Prieto. Our editorial assistant is Deboki Chakravarti. Our sound design is by Joseph Tuna Medish. And we couldn't make any of this without our patrons on Patreon. Thank you. And remember, the mind is not a vessel to be filled, but a fire to be lighted.
But one more thing. In 1916, H.W.M. Kendall, who was a British Army doctor stationed in India, wrote in the British Medical Journal that thanks to an abundant supply of frogs, ulcers, and thyme, he had learned to use frog skin grafts to treat not only ulcers, but also several battle-related wounds. So he would cut the skin off the inner thigh of a frog and leave the frog alive, apparently, and then put it on the ulcer, which I guess ulcer was kind of like trench foot is what he was talking about, it seemed like, because people had it on their legs. And this included one attempt at using frog skin to graft a bomb wound on a soldier's left buttock. But Kendall noted dressing on the buttock were difficult to keep in place, and the graft was unsuccessful. So you could have frog skin, but you can't have a frog butt skin. Maybe if you were really still, you could have a frog butt.
Yeah, I feel like we've got better elastics nowadays. We could keep that.
We could make it happen.
Frog butt graft.
Welcome to SciShow Tangents. It's the lightly competitive knowledge showcase. I'm your host, Hank Green, and joining me as always this week is science expert Sari Riley.
Hello.
And our resident everyman, Sam Schultz.
Hello.
I need to ask you two for tips on how to stay cozy during this very long Montana winter that is just beginning, because there's so much of it left, and I don't want it.
Today was the first day that I remembered that it gets so cloudy here. And I just feel like complete shit for a couple months.
You got really cloudy and you were like, wait, this is what's supposed to happen for months.
Yeah. I forget every time. But just don't ever leave your house. There's one tip for you.
I feel like that's a bad one.
I feel like the opposite.
I feel like that's not. I don't know if that counts as cozy.
Oh, I hate leaving my house.
Oh, wow. Okay.
My rule is I have to let my body see unfiltered sunlight at least once per day.
Oh, I have a yard I can walk into. My yard counts as my house.
Walk out, as long as it's not through a window. Like you actually breathe the air and the sun hits your skin, and then you're like, cool. Got it. Checkbox.
How long for?
Oh, just one deep breath. One.
Wow. One deep breath.
That's not very many, sir.
I'm going to suck this outside in and I'm going to take it inside with me. This one breath of outside.
Yeah.
I'm not good at staying cozy. I don't ever bundle up enough when I'm outside or anything like that.
I've got a pretty cozy coat. The other thing that I have is, I don't know, 12 like loose blankets.
Oh, yeah.
Just around.
A blanket.
I'm never more than 10 feet away from a blanket in my house.
That's probably the real secret.
Mm-hmm.
Is this a universal experience? Have you ever been sleeping over at a friend's house and they didn't have blankets enough for you, and so you had to like put a bunch of pillows and towels on you, or is this just me?
No, I've had this experience too. The towel. Nothing is sadder than sleeping beneath a towel that doesn't quite cover your feet if you're tall.
Right.
I would rather just go blanketless than even attempt.
It would get so cold at night because it would be like Florida in the winter and nobody knows how to heat their homes.
Oh, sure.
And so you just be like, put a towel on and maybe lay a pillow across your feet. Like, I don't need a pillow for my head. My feet are too cold.
Yeah. This is maybe a weird question, but I think about it. Would you rather have, if you have two little blankets, your top half covered by blanket or bottom half covered by blanket?
I think top half.
Oh, this is such an unpleasant question. Feet get so cold. I think bottom half. I think if I could tuck my feet into something, I'd be okay.
That's me. I gotta tuck my feet into something. Yeah. My top half can be a little chilly, but my feet need to be cozy for me to fall asleep.
If I wake up and my shoulders are cold, I get visibly angry. I'm like, what happened here? And it happens a lot. I don't know why, but it happens a lot. Every week here on Tangents, we get together to try to one-up, amaze, and delight each other with science facts while also trying to stay on topic. Our panelists are playing for glory and for Hank Bucks, which I will award as we play. And at the end of the episode, one of them will be crowned the winner. Now, as always, we introduce this week's topic with the traditional science poem, this week from Sari.
What is a snake, guys? Kind of looks like nature made a mistake, but it tries, moves through grass with a little shake, long-wise, warms itself on rocks at daybreak, sunrise. Of mice and birds they can partake, mostly pint size, but some are huge and earn their king namesake, like a prize. Their venom will make you ache or worse, surprise, your blood clots and you don't wake, a demise. But let's back up, pump the brake, and revise the image of the humble snake in our eyes. An ecosystem they can feed or break or catalyze, thoughts on how evolution's not fake, and there are ties to medicine and tech, the stuff we make. It's wise to learn from them, not just take their disguise. So let's normalize curiosity about these opaque allies.
Wow.
Whoa. You found every single word that rhymes with snake and guys.
Yeah. And I was missing one for snake, so I had to use the word snake twice. I tried my best.
Wow. What a respectful ode to the snake.
Which is the topic of today's episode. Snakes. Sari, what are they? I was trying to figure out if I knew, but I feel like I kind of do. Like I gotta guess. And I think there's probably a pretty clear evolutionary branch that has all of the snakes on it. And then there are some things that look a lot like snakes, but they're on the lizard branch. And there are things that look a lot like snakes, but they're actually fish, like eels. But there's snakes are a pretty clear branch of the tree that all have a universal one snake ancestor.
I don't know. I didn't look into the evolutionary divergence. It's possible that would there be convergent evolution?
The first snake.
So it's actually kind of hard to find the first snake because snake skeletons are small and fragile. So fossilization is pretty uncommon. So we can find more lizard skeletons and progression toward the snake, but we probably can't find snake great-great-great-grandma or anything like that. But snakes are squamates. Squamata are the largest order of reptiles. They are lizard snakes and worm lizards, which are those fake snakes that you were talking about. And they're all scaled reptiles. And then a suborder of that is Serpentes. And that is snakes specifically. Yeah. So they're all scaled reptiles, and then snakes are one of those groups. And they are ectothermic, so they don't generate internal heat. They need to get it from their environment if they want to warm up. They are amniotes, so they like lay eggs. They're vertebrates.
They don't always lay eggs, though.
Do they?
Some of them have live birth. I know this because I once told people that either pythons or boa constrictors gave live birth, but I was wrong because it was the other one.
And the big thing about them is that they have no front legs, and then some of them have a pair of like vestigial claws on the side of cloaca in place of back legs, or just nothing back there. But these bony thorns are called anal spurs, which are used to grasp each other during mating.
So that's all that Sarah knows about snakes. They're long and skinny, and they have butt spurs.
And they
yeah, some of them have venom. Some of them inject venom with their fangs. Some of them just have fangs. Some of them just have like various mouth structures, and most of them are non-venomous and either just constrict or eat.
Are they all like meat boys? They seem like they got to all be meat boys.
Probably. There's probably some article out there that's like the one vegetarian snake.
There are 3,400 species of snakes, but there are no herbivorous snakes.
Huh.
Yeah.
A snake could eat a banana so easily. We need to clue them into this.
Just be like, haven't you seen this?
It would be no problem.
It's perfect it's soft. It's snake shaped.
Yeah.
I want a banana right now.
A snake eating a watermelon would be very funny also.
Yeah.
So we should tell them that.
We should let them know.
They might want to do it for the views.
Yeah. Sarah, do you know what I did while you were telling us about snakes?
What?
I gave $100 to the Wikimedia Foundation because it's December and it's time for our yearly support of Wikimedia, a remarkable tool that is one of the only things left that's giving me hope in the internet. So thanks, Wikipedia, for all of the work that you do. I don't think that any of what we do would be possible, certainly not as easy, without the wonderful work that all of the Wikipedians do. Thank you.
So, where's the word snake come from?
So snake and serpent come from the same root word, basically the same root idea, which is to crawl or creep. And there are multiple Proto-Indo-European roots. There's sneg and also serp. But I feel like it's kind of like a jacket coat situation where some people used snake or words that sounded kind of like snake. Like there's like a lot of Swedish and Germanic. But then serpent was words closer to serpent was more in Old French or Latin. So like if you wanted to be fancy, you called it a serpent. Sure. And if you wanted to be just like regular, you called it a snake. And serpent used to be more popular for what you call this legless beast, limbless reptile. But in more modern days, snake has taken over for
serpent. Just
that.
too fancy. You'd be laughed right out of the room if you called him a serpent nowadays.
Yes, but how would I be laughed into or out of the room if I called them snegs?
I think everybody would applaud for you, welcome you with open arms.
Yeah, I think so too. And that means that it is now time for the quiz portion of our show. This week, we're going to be playing a snake. So, snakes, they can live pretty wild lives. You probably have heard about that. And sometimes people even get to see those wild lives in action. Well, this past summer, a group of researchers teamed up to count observations of a specific event that involves snakes, scouring academic journals, social media, and news sites for their analysis. So for today's Truth or Fail, I have 3 serpentine stories of what they were counting, but only one of them is the actual thing that they were counting. Which one is it? Were they counting, number 1, the number of times that snakes have been observed getting eaten by spiders? Or was it fact number 2? Were they counting the number of times that snakes have been accidentally dug up by a test rover at a Mars simulation site at the Jet Propulsion Laboratory? Or is it the third one? Were the researchers counting the number of times that rattlesnakes have been found curled up inside fast food signs for warmth at night?
Oh, that's scary. scary. They're all scary.
So
the Mars rover one isn't too scary.
No. Yeah, nobody's going to get bit there. It's a rover. We're all good. So it could be the snake-eating spiders that they were counting. It could be the number of snakes found by a rover, or it could be fast food coziness with a number of snakes hiding inside of a sign.
Would be scary if they dug a snake up on Mars, though.
I don't know about scary. I think that'd be amazing. I'd be very, very excited. I'm not there. There's I'm way more afraid of the snakes that are here than on Mars.
The implications are chilling, though. God. A snake eating a spider. That's illegal.
The opposite way. Better. Spider eating snake.
Snakes eat spiders all the time. We're talking about spider eating snakes.
Yeah. Spider just slurping them up like a spaghetti.
Yeah, I guess. Yeah. I think probably they do it like anything else, where they like wrap them up and then they liquefy the thing inside of the little pouch and they suck it down.
I feel like there would only be a handful of spiders that could do this because of spider webs not being strong enough. Or like it needs to be one of those big bird catcher spiders that's like bird catcher because we've seen it catch birds, but it's actually like anything big. So
something
it counts
that's ambushing a snake instead of just trying to catch it in a web. Right. I feel like there was a famous video, like a big video going around a few months ago of a spider eating a snake.
Huh.
Why would you be watching it, Sam? I feel like
because my dad sends me every spider video that he finds to make me extremely uncomfortable.
The Mars rover testing sites, I guess snakes would bury in sand. Like that makes sense. And I don't know.
But would that be popping up on like social media? Would they be scouring social media to figure that out? They just have to ask the people who worked on at JPL, right?
Or whoever was doing the tests.
Yeah.
Maybe those JPL people don't like write it down. They just tweet a lot.
Yeah, that's probably it.
And then the fast food signs, that one makes the most sense to me.
Yeah, me too.
If I was in a desert, I would want to curl up somewhere warm. And what else but the glow of golden arches beckoning me? Would you tweet about it if you saw a snake suddenly pop out of a Taco John's sign?
Yes. Yeah, no, I would make a TikTok. I would tweet it. I would probably talk about it in a video. I would do all of the things.
Yeah, and if you worked at Taco John's, you'd be like, check this out, guys. Open it up. Let all the snakes out. I think I'm going to go with the spider-eating snakes.
Sam's going with spider-eating snakes.
Really?
Because I think I'm being tricked because there was a video about this that I saw and maybe Deboki extrapolated. But if I saw a video, there's more. That's, it's a thing.
Okay. I'm still going to go with fast food signs because Sam's dad doesn't send me spider videos, so I simply don't know.
Well, the good news for Sam is that indeed a lot of different spiders make meals out of snakes, at least 319 of them to be exact, based on a meta-analysis published in the Journal of Arachnology. Now, this is not individual species, this is individuals. A third of these observations came from documented in journals. The rest came from news and social media sites. In total, they found that spiders have eaten snakes on every continent except Antarctica. 80% of the observations were made in the U.S. and Australia, though.
80%? Is that what you said?
80%, yeah. It was just more of us taking pictures and posting on social media here, probably. Some spiders could take down snakes that were 10 to 30 times their size. The largest snake that got eaten was over a meter long. But most of the snakes were young, freshly hatched little baby snakes, and their biggest nemesis was the black widow spider, which has both very strong venom and very strong silk. And that helps when it comes to catching big prey. The bigger snakes were all killed by orb weavers or tarantulas, and the most commonly eaten snakes were garter snakes and rat snakes, which are just because there's a lot of them around, probably, more than their size. Now, as for the Martian snakes, so there's a Mars yard at JPL, and it is made out of the southwestern rocks and stuff, and they do sometimes find snakes there, but they don't. Apparently, I don't think that they've ever dug one up. They haven't been surprised by one. As for fast food signs, I don't have any good data on fast food signs, but I do have good data on the fact that during the beginning of the pandemic, they parked a bunch of airplanes in the Mojave Desert because they didn't need them, and they were like, let's keep them here. But the engineers had to keep the planes healthy and running and making sure that they were operational for when things started working again. And they did quickly find that around the tires specifically and the brakes of the planes, rattlesnakes would be like, this is a nice spot for me. And so they quickly had to improvise some strategies, which mostly involved banging on things with brooms.
Very scientific.
So Sam is going into the break with a 1-0 lead. Next up, it'll be the break and then the fact off. Welcome back, everybody. It's time for the Fact Off. Our panelists have brought science facts to present in an attempt to blow my mind. After they have presented their facts, I will judge which one would make a better TikTok, and then I will choose that one and probably give it some number of points that will alter the outcome of the game. Or not. Who knows? But to decide who goes first, I have a trivia question. Are you ready?
Yeah.
So for animals with no limbs, snakes are pretty impressive travelers. Some tropical tree snakes can jump and fly from tree to tree by flattening their bodies down and undulating wildly through the air. But they don't always jump at takeoff. So how much farther does a snake glide after a jumping takeoff compared to a non-jumping takeoff? And this is like not in meters, but in like how much further in like percentage or like multiples.
Okay. So sometimes they're just flopping off the tree, and sometimes they're boing?
Yeah, correct.
Okay. How much can a snake boing?
How much could a boing snake boing?
I think it can go twice as far.
Twice as far. Twice as far, Sari says.
I think they can go 1/4 as far.
It doesn't matter, Sam, because Sari got it right on the nose.
They're good at boinging,
exactly,
huh?
Exactly 2 times.
Wow.
Amazing.
Sorry I interrupted you, but look, we got things to do. We got facts to fact. Well, congratulations, Sarah. That means you get to decide who goes first.
Thank you. Sam, since you're so confident, go first.
Oh, no. So snakes don't have a lot of ways to separate their prey into discrete, easy-to-swallow pieces, like claws or jaws full of teeth made for ripping and chewing stuff up. So many of them famously swallow their prey whole. And for the animal being swallowed whole, that is probably unpleasant enough to begin with, since as far as I can tell, animals tend to get swallowed alive and asphyxiate inside of the snake.
Sure.
Which sucks. But in 2020, a team of researchers confirmed another, even more sucky way that a species of snake eats its prey. The Asian kukri snake generally eats toads, big lumpy toads. And sometimes when they are eating these toads, according to video footage studied by this team, the snake will cut the toad's belly open with a specialized cutting tooth, insert its head into the still living toad, and start thrashing around in a death roll similar to an alligator's death roll.
Why?
So after rolling for a while, the snake will start eating the toad's guts one at a time. And the death roll is kind of a misnomer because it does not in fact kill the toad, since the toads being eaten alive have been observed to be alive for 4 hours during the process of being eaten. And instead, they think that the role might be to loosen up the toad's guts or to, quote, force the guts out of the toad's bodies. But the researchers aren't really sure. That's not the only thing that they're not really sure about, because the snakes have also been seen eating the toads whole. So it's sort of unknown why sometimes they eat the toads one organ at a time.
Oh, I know exactly why.
Well, okay. Tell me after. Why? Tell me why.
Well, it's because they're full and they don't want a whole toad. It's like when you go to Chipotle and you're like, I can't do that. So you open your burrito up and you sort of eat a little bit of it from the inside.
Just have a little snack.
Yeah.
And then wrap it up and save the rest for later.
Yeah. You don't want the whole toad burrito. You just want the filling.
That's a great hypothesis. There's another hypothesis that it could be to spread out the dosage of the toxins that snake gets from certain toads. But they have also been seen eating toads that are known to be poisonous whole. So that might not be why. It's probably just that the snake knows how much it can swallow at once. And so it eats larger toads gut by gut. But the snakes have also been observed doing the cut the belly open, stick your head in, death roll maneuver to toads that they end up swallowing whole. So they might just be assholes and like doing it or something like that. And in 2021, they found 2 other species of kukri snake that feed this exact same way. So it's just this whole family of weirdo snakes. And this can be an inadmissible little bonus fact in your final decision. But I was curious if there were other snakes that ate their food in weird ways like that. And it kind of seems like there aren't. There aren't very many other snakes that eat their food one little bit at a time instead of whole. But there are a kind of snake called the crab-eating water snake. And they eat crabs. And what they do is they flip the crabs upside down and eat their legs off one at a time. And they might even have modified molar-like teeth to help them chew the crab legs, because they have the legs have teeth marks on them when they take them out of their stomach.
It is a crab leg, so it does not seem like it would be particularly easy to get done.
No.
Oh boy. Oh man. Gee. I'm looking at one.
Are you watching him do it?
He's got a big old crab leg in his mouth.
Oh, that guy, yeah. And then there's also video of the guys with their heads in the toads flipping them all over the place.
Oh, yeah. I haven't watched that yet. But, well, Sari, you've got a challenge to overcome, though I will say, I don't know if I want to tell people about this because it is terrible.
It's kind of sad.
You really got to wiggle those boys around.
Yeah. And toads ain't never hurt anybody. They're just minding their own business.
You don't want to be making a TikTok of a snake thrashing in the background with.
No, I don't think I could put the video on it. You could give the warning, but
I made a miscalculation.
Yeah,
too violent.
I don't know. We'll see. Maybe Sari's will be. They do that, except it's with like puppies or something.
Yeah, something even horrible. No, mine is also about eating though, but different snake.
That's kind of most of what they do. Really?
Yeah.
It's a lot of it.
Most of the interesting stuff about them. I'm going to talk about Burmese pythons, which are fairly iconic in the snake world because they've got that tan and black snake skin pattern, and they can grow really big, over 5 meters or 16 feet long. And they're an invasive species in the Florida Everglades because of humans being dumb. And these danger noodles can eat. So they're one of the non-venomous snakes and hunt by constricting prey until it can't breathe or passes out so they can swallow it whole. And a lot of the clickbait you see involve Burmese pythons swallowing ridiculously huge creatures that are about the same body mass as them, like deer or alligators.
Mm-hmm.
And these massive meals require them to stretch ligaments in their jaws and skin in a kind of grotesque eating feat, and then they don't need to eat again for months. But what's even more remarkable biologically, in my opinion, is what's going on at a cellular level during these feasts and famine. For example, a malnourished python's intestine is pretty sparse, with thin, barely there cell layers and short microvilli because they don't need much surface area to absorb all that nothing in their body. Mm-hmm. But as soon as they snag a meal, their metabolic rate can skyrocket up to 44 times. Within 24 hours, the intestinal cells increase in surface area, width, and mass, and in less than a week, there's as much as an 80% increase in intestinal cell count. Wow. Other organs swell too, like their liver to filter blood, their pancreas to pump out enzymes, and, most weirdly to me, their heart, in a process that's known as cardiac hypertrophy. So in a 2005 study, python's heart muscle mass increased by about 40% within 48 hours to pump blood and oxygen and nutrients around and help get all the gastric juices flowing. And if I'm doing my math estimate correctly, I've never seen a python heart, but I think their heart goes from somewhere around the size of a grape to a strawberry, which is like big when it's that small.
Yeah. But like a slightly larger than average strawberry. So we're talking significant.
And in a 2011 study, scientists deduced that what causes this massive organ growth spurt is really fatty blood. In fact, when they drew blood from the recently fed pythons, it was cloudy because of all the lipid molecules floating around, especially myristic, palmitic, and palmitoleic acids. Something weird is going on with this particular biological cocktail because when the researchers took this trio of fatty acids and infused it into an unfed python's blood, it stimulated heart growth the same amount as if the python fed or if they infused blood plasma from a fed python. And in most mammals, a huge jump of lipids in the blood like this would probably lead to some sort of buildup or disease.
Right, yeah.
But these infusions even stimulated heart muscle growth in living mice. Not liver or skeletal muscle growth, though.
What the heck?
I mean, I was going to ask, should I drink the fat snake blood?
I don't think you should drink it, but you should get an IV drip of it, and then your heart will swell.
Inject it straight into your body.
And then I'll suddenly be a sportsman. No, sportsman is a different thing. What is it called? An athlete.
An athlete.
You'll be a good sport.
You're gonna need a lot of snake blood.
I'll be a good sport. The fact that it affects a mouse's organs is very weird.
Yeah.
Yes. Yeah. And that's as far as they took the experiments. So I think they still have a lot of questions because I still have a lot of questions.
They should have kept going.
If this was 100 years ago, they would all be shooting up snake blood.
This mouse is too strong now.
Yeah. And they say that this could be useful not only just like in understanding how lipids boost organ growth, and then like the snakes don't stay that way. It shrinks again depending on what they need. But human heart muscles are like really complicated to understand. And we get conditions like hypertrophy that aren't great.
Yeah.
Like sometimes it is an athlete, but sometimes it's negative. And so we could learn a lot about heart muscle from the wildness of these snake hearts.
That's very cool. I knew a lot of that about snake organ regrowth, but the lipids in the blood is very weird. One, because like that's something you usually don't want. And two, the fact that you can transfer that to another snake or even to a organism that is only very distantly related to the snake. It's very cool. I was definitely going to give Sam the point until I heard that. So instead, I'm going to give you equal points, which means that Sam still comes out the winner.
Oh, thanks.
And that means it's time to Ask the Science Couch, where we've got a listener question for our couch of finely honed scientific minds. It's from Emily17, who asks, I know that there are a set number of recognized snake locomotion strategies. Are they each suited for different things, or do some snakes move in silly ways just because evolution was like, why not? It's definitely not why not. There's definitely good reasons for. I can only think of two, but I'm sure that there are more than two.
What are the two you can think of?
Sidewinding is the weird one, and then normal, which is how snakes move. Yeah.
Yeah, sidewinding is specifically on sand, and it just helps lift their bodies up so they don't have as many contact points with the ground because it's for like hot sand or because sand is slippery. You don't want like your whole body to really mush in there. Otherwise, you'll slide down.
So you can dig a little further in with the parts that are touching rather than everything being a little shallower.
Okay. Yeah, that's my understanding of the physics of sidewinding. Normal, in fancy terms, is called lateral undulation, which makes sense because lateral is like sideways and then undulation is the wiggly. And that is where all points along the length of the snake are in contact with the ground and are moving back and forth. So it's used for rough ground, anything where more grip or surface area is helpful and possible. So like they undulate while gliding. The gliding snakes do. It's also useful for water snakes, so the ones that like travel on the surface of the water. A third type is called concertina locomotion. And so it's kind of like an accordion where half the snake moves and then the other half catches up. And so it's like the front half jumps forward and then the back half jumps up. And the front half jumps forward and the back half jumps up.
Weird.
And so this is helpful for things like tunnels or climbing trees in a lot of ways because it's like big bursts of energy, but it's also the least efficient method of locomotion because you have to like do these big bursts of power to get going. A new one, newly discovered, is lasso climbing, where a couple snake species just like form a circle around a pole and kind of like wiggle their way up.
What the heck?
They like form a loop and then climb, which is extremely weird. You can find videos of this. And so there are more snake movements to be discovered. But the one that I wanted to spend a little bit extra time on, even though it sounds boring, it's the one that scientists are generally most interested in, is rectilinear moving, also known as rib walking. So this is the kind of movement, like if you see in a big python, it's moving straight forward in a line. So instead of like slithering in S's like a snake, it just kind of like oozes forward.
Inching. Yeah.
Yeah. And it's specialized muscles that are attached between their rib bones and the belly skin of the snake are like carefully controlled to like bloop forward in little goes. But
so they got little feet nubbies on their bellies?
Yeah, they're just walking on their little snake feet.
Oh.
Yeah. But it's like if instead of snake feet, they had like, they were like a centipede down there. Because like each of their ribs has like a muscle attached to it, and it just kind of like blorps forward all equally, and they just kind of squish forward, providing traction with the ground, but also like that forward momentum that becomes really fluid and seamless. And this is the one, if you've heard about snake-inspired robots, to either go into pipes or to go on other planets where we're not sure what the terrain will be, or to go into wreckage to look for whatever is in there, like to help rescue missions and things like that. This is the locomotion that they're studying, because it's just like such a precise synchronization of muscle movement that can squeeze snakes through small spaces. And it's apparently very complicated and very hard to mimic. But snake brains are just like, I got this. I'm going to move in a straight line, and then their muscles do all the rest.
Right. That's the nice thing about being a snake, is you don't have to, or anything. Like, you can throw me a ball and I'm not going to do the calculus to figure out when it's going to get to my hand. I'll just hold my hand up.
Because you're an athlete.
Because I'm a sportsman.
So do snakes have to pick one? Can some snakes do multiple of these, or?
I think most snakes can switch between several of them. So one paper I was looking at, I think, was looking at garter snakes, and they did lateral undulation. So like normal snake, concertina, locomotion, and the rectilinear. And it just depends on like what environment they need to navigate through and how much energy they're willing to expend. So it's not like you just pick one per snake.
It looks like fun to do snake movement. I feel like that would be fun. It doesn't seem like, one of the things that I think, I don't know, it feels like this is part of what creeps me out about snakes, is that it doesn't seem like it should work. It's like, how are you moving around so well? You don't have feet.
How'd you get in a tree?
How'd you get in a tree? You don't have hands. I can't climb a tree, and I got like 4 limbs.
That part does look fun. The eating big stuff to me has always looked like, no thanks. I would just eat spaghetti if I was a snake.
Very time consuming and unpleasant.
Yeah.
If you want to ask the Science Couch your question, follow us on Twitter at SciShow Tangents, where we'll tweet out topics for upcoming episodes every week. Or you can join the SciShow Tangents Patreon and ask us on our Discord. Thanks to @Ofio134, Saida, and everybody else who asked us your questions for this episode. If you like this show and you want to help us out, it's really easy to do that. You can help us out by going to patreon.com/SciShow Tangents to become a patron and get access to things like our newsletter and our bonus episodes. One of the tiers that you can get is an in-episode shout-out, which I mention here because we have someone to shout out. Caitlin wants to dedicate her shout out to her boyfriend, Kenny. Happy almost anniversary to you both. Second, you can leave us a review wherever you listen. That's super helpful, and it lets us know what you like about the show. And finally, if you want to show your love for SciShow Tangents, just tell people about us. Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
And I've been Sam Schultz.
SciShow Tangents is produced by Caitlin Hoffmeister and Sam Schultz, who edits a lot of these episodes along with Hiroka Matsushima. Our social media organizer is Paolo Garcia Prieto. Our editorial assistants are Debuki Chakravarti, Emma Dowster, and Alex Billow. Our sound design is by Joseph Tuna Medish, and we couldn't make any of this without our patrons on Patreon. Thank you, and remember, the mind is not a vessel to be filled, but a fire to be lighted. But one more thing. It might seem like snakes are all tail, but that is not true. There is a section toward the end of a snake where their stomach ends and their tail begins. And that is where their cloaca, or their waste vent, is. What it says. And some snakes, like the Sonoran coral snake and the western hook-nosed snake, use their cloaca for self-defense. They push air out of the vent to make a popping sound that deters predators. So basically, their self-defense mechanism is farting. Just like my son.
Does he weaponize his farts?
I mean, I don't think so, but he does fart on me and laugh. So it's not true self-defense, but he is certainly enjoying it.
Yeah, well, no one's eating him, so it's working.
It's true. welcome to SciShow Tangents, the lightly competitive knowledge showcase starring some of the geniuses that make the YouTube series SciShow happen. We're joined, as always, this week by Stefan Chen. Have you ever been to a monster truck rally?
No.
Oh, come on, it's so good.
I've never been to any of the demolition derby, monster truck.
Oh my gosh. The moment this lockdown ends, we're finding a demolition derby and we'll take all of you to it.
Demolition derbies are so fun.
They are stupid fun. I went and I was ready to enjoy it ironically. And then I was like, oh no, this is art.
Yeah.
What's your tagline, Stefan?
68 and freezing.
Sam Schultz has also joined us today. Sam, what is the number one top cartoon?
Batman the Animated Series. That's the best cartoon show ever made, I think. And Avatar The Last Airbender are tied for the best cartoon shows ever made.
Okay.
Avatar The Last Airbender might be the best television show ever made.
And what's your tagline?
It's 5 o'clock somewhere.
I'd like the song better if it were posed as a question. Sari Riley has also joined us. And Sari, what's your tagline?
It just got very dark in here.
That's great. It's a really good tagline, but also it seems like it actually did. And I'm Hank Green, and my tagline is, you can't really count on the sun. Every week here on SciShow Tangents, we get together to try to one-up, amaze, and delight each other with science facts. We're playing for glory, but we're also keeping score, and we award Sam Bucks from week to week. We do everything we can to stay on topic, but judging by the intro of this podcast, we won't always be great at that. So if the team deems you tangent unworthy, we'll force you to give up one of your Sam Bucks. So tangent with care, especially about motorsports. Now, as always, we introduce this week's topic with the traditional science poem. This week, for the first time in a while, it feels like, from me. This poem is entitled Daydream. It has a title. Who's that actor getting out of that Mercedes-Benz? I don't know, but you saw it using an anatomical lens. Oh, he's that Australian. I think his name is Russell. I can't see him, but you're doing it with your ciliary muscle. I wonder how old he is. He looks like he could be a boomer. I don't know, but I know that his image travels through your aqueous humor. And who's that with him from Wonder Woman? Ah, what a gal. You'd have a much harder time seeing her without your Schlem's canal. She's on ice skates. She just did a sow cow. I think it was quadruple. I didn't see it, but you only saw it with the help of a pupil. And Russell, now he's walking an animal. It looks like some kind of chimera. I don't know what it is, but neither would you if you didn't have a sclera. Oh, and now Gal, she looks so cold she could have hypothermia. Maybe so and maybe not, but you're seeing it with a cornea. That one was a stretch. I'm starting to think that you can't see anything at all. That's true, my friend. I don't exist. You're staring at a wall.
Oh.
Twisted it around at the end there.
Uh-huh.
Who on earth is the Australian guy named Russell?
Russell Crowe from Gladiator.
Yeah.
I assume there's a specific movie, and does it have to do with the topic, or
no? It's just a daydream,
or
man.
just that we're watching a movie.
Just, okay, thinking. It's not even a movie, Stefan.
No,
we've left Stefan behind.
I haven't seen a lot of movies. I thought maybe there was like a movie that was called Eyeballs,
starring Russell Crowe and Gal Gadot. It's especially great because their names rhyme, which was not intentional.
Which didn't even rhyme them in the poem, right?
Did not.
Half of those parts of the eye I've never heard of.
Yeah, Schlem's
but
canal,
then you got,
that was new.
Yeah, what the hell is that?
It moves aqueous humor around your eye, which apparently is important for some reason.
Sounds important.
Yeah. So our topic for the day is eyeballs. I think it's specifically eyeballs. So if anybody comes to me with eye spot facts, then you're in trouble.
Ooh.
But we'll see. We'll see when we get there. Sari, what is an eyeball?
So an eyeball, I guess, to distinguish it from an eye spot, is a specialized organ of the visual system. So instead of just like a specialized patch of cells, it has specialized beyond that to be like such a cluster of cells that they're like, that's a different tissue. That's a ball, in fact. And it's used for vision.
They don't have to be balls, though. They can be like discs or football shaped.
Owls have like tubes or something, right?
Yeah, I think they're like long in some way.
Mm-hmm.
Do compound eyes count?
I think a compound lens is an eye, like an eye that's a ball, but it's not an eyeball.
Well, colloquially speaking.
Don't you dare edit that out either.
I think eye spots are eyeballs. I think compound eyes are eyeballs. What slugs have on top of their little things, those are eyeballs.
Sam thinks it's all eyeballs.
To me.
I disagree. But eyes, they see. There are things that see that are ball shaped. Do you have an etymology of eyeball? I don't know where the ball part comes from and the eye part. I know where the word eyeball comes from.
I didn't look up eyeball specifically. Like there wasn't in the etymology dictionary, but eye is from the Proto-Indo-European root OKW. Not sure how you pronounce it. In my head, it's like the Cardi B okert thing that I can't do with my mouth. It's like one of those things where humans have had eyes, and so we've had to describe them in some way.
So it's old one.
So, yeah, OKW means to see, and then the Germanic forms evolved from there from like augo or oog or auga. any combination of like G's, A's, O's. And then eventually made its way to eye.
I think people used to think that Shakespeare invented the word eyeball, but I think they found an older thing that predated him just barely. But it's from about that time. Whenever that time was, I have no idea.
And now I think it's time for One of our panelists has brought 3 science facts for our education and enjoyment, but only one of those facts is real. The rest of us have to figure out either by deduction or wild guess which is the true fact, and if we do, we get a Sam Buck. If we don't, then the presenter, who is Sam this week, gets a Sam Buck. You can play along at home at twitter.com/SciShow Tangents, but don't click until you've heard all the facts. Sam, what are your facts for us today?
So if you have eyes, you're pretty familiar with the way that eyes move. They go up and down and left and right, pretty much like on the same axis. But there are some animals out there that can move their eyes in weirder and more fun ways than people can. So which of these is true? Number 1, many sharks and rays have eyelids that they can close to protect their eyes when they're attacking prey. But the guitar fish, which is a ray that basically looks just like a flat shark, does things a little differently. It has a muscle in its head that can yank its eyeballs into its skull. Number 2, bats spend pretty much all their time that they aren't flying around hanging upside down, which means that they're always seeing the world upside down. But the bulldog bat family has developed a special trick, eyes that can rotate around so that everything is right side up. Scientists have found that this adaptation helps them get oriented faster when taking flight, reducing midair collisions.
No fucking way. But yeah, go ahead. Keep going.
Number 3, the Spinosaurus had many adaptations that lead researchers to believe that it's the only dinosaur able to swim. But some other researchers believe it has another unique distinction. It's the only dinosaur with independent eye movement. It might have had eye structure similar to a chameleon that both protected much of the eye when it was underwater and allowed it to track multiple swimming targets at once.
Ooh, okay. I like them. So we've got our 3 facts. The guitar fish can use muscles that pull its eyes inside its skull. The bulldog bat can rotate their eyes to maintain orientation when hanging upside down, or the Spinosaurus has skull structures that suggest they had independent eye movement. I've already said my piece about the bat.
Well, maybe there's they can put little lead weights in there so it's always right side up.
Oh, yeah. I like that.
It's like a gyroscope in nature. I can absolutely believe that there's something weird out there where it's like, oh, it just rotates around. It's in fluid, and the only connection is something that we've never seen before. Mm-hmm. We're using it for space stations now.
And I really want them when they're flying to do a barrel roll, but their eyes stay in the same orientation while they spin around.
Yeah. Their eyes don't necessarily stay in the same orientation. They can move the orientation of them.
Right. It doesn't just float there like one of those globy things that you spin, but the globe stays in the same place. We've got guitar fish. This seems perfectly reasonable that a fish would be able to yank its eyes into its skull.
Where's the room for it, though? We don't have any room in our skull for eyes to be sucked in.
Well, not guitar fish.
Okay.
Fish got empty heads, man.
There's nothing in there. Sari, have you ever tried to yank your eyes into your head?
No.
Okay, try.
But
I need to see you. Look at me and try to yank your eyes into your head. I just want to see what it looks like.
No.
Don't do it. Because what if you do it?
No, I'm not going to.
I think if you plugged your nose up real good and snorted really hard at the same time.
That's going to blow my eyes out.
Then maybe something would happen.
All right, Sam, you seem to have all the like you've got it figured out. Why don't you do it?
Because I know I could, and I couldn't get him back out if I did.
Too powerful.
I don't want to lose him.
Okay, I'm gonna do it.
Oh, he did it. Horrible.
All right, and then our last fact also seemed really cool. The Spinosaurus skull having structures. So it had chameleon eyes, and that seems like that would be interesting because we like this surprising thing about dinosaurs. We like figure out these stupid little amazing things by looking at like muscle connection points, and we're like, oh, the only reason that would be there is if they had chameleon eyes.
And I could see it being a weird adaptation when eyes were first, I don't know, earlier on in eye development, where it was like, of course it would come up more than once that it's cool to watch prey in more than one place because you're hungry and you want to protect yourself and find more things to eat.
I'm going for the alligator fish.
The guitar fish?
The guitar, yeah, that one. Alligators and guitars, they look a lot alike.
I will also go for the guitar fish.
Whoa.
Yes.
Oh, no. I was leaning towards guitar fish, but do we want to go all in? All right, let's do it. Let's make a gamble. Wow. Everyone on guitar fish.
Everybody
We're
on
all
guitar
in,
fish.
baby.
Ooh, that's so scary. So now it is time for you to go vote at twitter.com/SciShow Tangents and to see what you pick. Do you vote with us with guitar fish, or do you vote your own independent way? Free yourself from our tyranny. Sam, what is the true fact?
Well, look, okay, it's the guitar fish.
Oh God. That was scary.
So the guitar fish can suck both its eyes into its head. It has one long muscle that runs along the bottom of its skull and hooks up to like the muscles around its two eyes. And when it's about to get a crab or whatever they eat, crabs are one of the things they eat, and it's going to dive into the dirt, it sucks its eyes up into his head and gets a crab. And other rays and sharks do not do this. They just have like a protective eyelid that goes over their eyeballs. But they're looking at other ones right now, actually, to see if maybe they do it. And they also have a protective lid, but the guitar fish don't have a lid.
They don't have a lid. They just suck their eye in.
As far as I could tell, they just suck their eye in. It can go 2 inches, and it goes 2 inches into their head.
Wow, that's far.
Seems quite far, yeah.
Does their skin just kind of pucker over it? Is that what protects it?
Yeah, it looks weird.
Yeah.
There'll be a picture of it in the sources, but
I'm looking at it right now, and I'm getting a physiological vibe from it.
It's got a butthole vibe.
Yeah.
There's a clenchiness to it.
Yeah. The bat thing I made up. It would be cool if bats could do it. It seems like it would be really useful for them. But goats and sheep sort of can move their eyeballs on that different axis than we can. They have eyes with horizontal pupils, obviously, so they're good at panoramic vision. But when they bend their heads down to graze, they can move their eyes up to 50 degrees to match the horizon to keep the panorama going, so they're not just looking at the sky and the dirt.
Yeah.
And bats do smack into each other a lot when they're flying out in their big groups at night, but they're generally fine. They recover from it and do not die from smacking into each other or anything. And Spinosaurus was really the only dinosaur that they think could properly swim. It had big flat feet and super dense bones that let it be able to submerge itself. And I guess other dinosaurs maybe had too porous of bones and would float or something like that. And its nostrils are set really far back on its head, so it could keep them above water, but it did not have special eyes, as far as they know. Maybe it did.
It's true.
There's no way to actually prove I'm wrong.
Oh boy, we went all in. Sam, I'm so sorry.
No, that's okay. I mean, you needed the point.
I don't
Stefan
know.
and Sari are still locked in a tie, I think.
All right. Everybody, we're going to go for a short break, and then it'll be time for the Fact Off. Welcome back, everybody. We've got Stefan and Sari tied with 1, Sam with none, and me in the lead for once with 2 points. But I will not end in the lead because Well, because I don't have any more opportunities to get points. Because now it is time for Stefan versus Sari in the Fact Off. Two panelists have brought science facts to present to the others in an attempt to blow our minds, and we get a Sambuck to award to the fact that we like the most. And to discover who's going to go first, we're going to answer a trivia question. Of the 6 million cones in the human retina, approximately how many of them are red cones? You can say a number or you can say a percentage, but the percentage would probably be easier.
I'm going to say 1/5.
1/5 of the
That's
cones.
interesting. This question only makes sense if it's not split evenly. But I don't know. Red seems more important to me. It's also my favorite color, I think. So I'll say 2/5.
Hey, we didn't say fractions or
40%. 40%.
Yeah, 20%. We can do quick math.
You're making this
0.2.
so hard for us. No, I can do fractions. Now, the actual answer is 2/3-ish, 64%.
Whoa.
Yeah.
Yeah, red's the easiest
Red
color to
is
see.
better.
Yeah.
I thought it
Okay.
was green. I thought we were all in on green.
No, green's the hardest to see, I think.
The terrible news is that I don't know why. I don't know why there are more red cones. I just know that there are. And that means that Stefan gets to go first or choose who goes first.
Yeah, sure. I'll go first. Let's do it.
Okay.
So diabetes is a disease, and the main long-term complication with diabetes is that your blood vessels get damaged. This includes the blood vessels in your eyeballs. And so over time, this can lead to diabetic retinopathy, which is also known as creeping blindness, because as the blood vessels are damaged, there's less blood flow, and so you get less oxygen to the nerve cells in your retina, so they eventually die. Apparently, the body tries to regrow the blood vessels, but it does a bad job, and that makes everything worse. So the two things that it seems like you can try to do is inject medicine into the eyeball that inhibits that blood vessel growth, or you can use a laser to burn away cells on the peripheral parts of the retina, and that reduces the overall oxygen needs of the eyeball so that the limited resources that do make it up there can get focused on the more important cells that are at the center of the retina. And we suspect that a lot of the damage that's happening in the eye happens at night when we're sleeping and everything is dark, because we have the rod cells and the cone cells. Rod cells work better in dimmer light, and that's how we have our low light vision. And so when it's dark, the rod cells' oxygen needs double. And so it needs more oxygen. It's not getting it more damage. So there's this idea that if we could keep the rods from experiencing darkness while people are sleeping, we could prevent them from needing more oxygen and prevent that damage. And so previously we had tried using like sleep masks that shine lights into people's eyes.
This is great. We're going to save their vision, but also it's like actual torture.
Yes. Unsurprisingly, people found it distracting to have lights shine in their eyes while they're trying to sleep. And also, I guess our eyes roll back once we're asleep. And so like the retina's not even receiving that light anyways at that point. So Colin Cook, Caltech graduate, came up with this idea to use glowing contact lenses to achieve that same effect, but without needing to do anything invasive or painful or distracting. It's a standard contact lens, but then it has a circle of tiny tritium-filled vials. And so that's like a radioactive version of hydrogen gas. And then there's a phosphorescent coating on these vials. So they glow. They're very tiny. Each vial is like the thickness of a few human hairs. And they're arranged in this circle. But the circle's large enough, and like because it's right up against your eye, it's big enough that while you're awake, the circle is outside your field of view, so you don't see it glowing, because it's glowing all the time. But then when it gets dark and your pupils dilate, then they let in the light from this glowing circle.
Oh my God.
And that stimulates the rods, and so their energy needs don't jump up. And they also noted that because this light source is moving with your eye, it's a very like constant thing, and our brain is good at like tuning those kinds of things out. So after a while, you don't even really consciously register the light. And so it doesn't distract you from falling asleep. And in the testing they've done so far, they found that the rod activity was reduced by 90%. with people who are wearing the contacts. We don't know yet if this will actually translate to reducing the blindness, but that's like the next steps. But it's just seemed like such a cool thing.
Tritium does release ionizing radiation, which is why it is able to make this stuff phosphoresce. I don't know if I want to put. It's not very much. I understand it's not very much.
Tiny vials. Yeah.
I don't know if I want to put ionizing radiation on my literal eyeball.
Yeah, it feels like that wouldn't help with the damage in the long term.
Yeah.
Like some extra DNA damage in some cells might just pop off in there.
Does seem worrying. I don't want to get eyeball cancer. But it also occurs to me that this would be a good way to prove out this theory at the very least. That the problem is the overactivity in these cells while there's no light. Because they work harder when there's no light and need more oxygen.
Yeah, it seems like we just haven't had a good way to actually like get people to comply with whatever like protocol they're, you know.
It also seems to me like wild that our bodies will expend more energy during darkness. Like it's harder to not receive information than to receive information for those cells.
They're just like, oh shit, it's dark. I'm going to try really hard to see, but it's the darkness of your own eyes being closed.
Even though like I know that your eyes are going to be closed for like 8 hours a day. I'm still going to try really hard the whole time.
Exercise.
I guess so.
Yeah, the only part of your body that exercises while you sleep. If I could capture that from my freaking pecs. Okay. I love that fact. And I love that this is a real thing that exists and that they've used. All right, Sari, what do you have for us?
So nature is full of symmetry, and we also really like recognizing symmetry when we see it, whether it's the bilateral symmetry of our bodies or radial symmetry in a snowflake. I guess I have a tangent in here already. I think this is why we have such a fascination with asymmetrical things like heterochromia, iridium, when a human or a dog or some other animal has two different colored irises, like a brown eye and a blue eye. And we're like, ooh, asymmetrical. That's cool. So that eye phenomenon is just caused by a genetic or a traumatic variation in pigment for some reason. But there is a much more extreme asymmetrical eye situation in the animal kingdom. And let me introduce you to the cockeyed squid. They live in the mesopelagic part of the sea, so 200 to 1,000 meters deep. Not the pitch black darkest, but not exactly bright from sunlight. And to survive here, they have two radically different eyes. One is a small eye with a clear lens, so it looks black when we look into it. It's like fairly standard for a squid eye. But the other one is comparatively giant and bulbous with a big yellow lens. And in a 2017 paper, Kate Thomas of Duke University did studies on 30 years of 152 or so sightings of Histiotuthis heteropsis, which is one of the species of the cockeyed squid. And they did some simulations of these two different eyes to figure out why they are so radically different. So the squid swims along in what looks like an upside down orientation to us with like tentacles faced towards the surface so that its eyes are oriented in different directions. And the small eye almost always points downwards and scans the deeper ocean for any flashes of bioluminescence in the otherwise dark water. And the size of the eye doesn't really matter here, just as long as you have some sort of like vision thing, a light sensing organ to catch a flash coming from below. And the big yellow eye almost always points up towards sunlight to look for the silhouettes of anything swimming above it. And in that case, the increased size greatly helps the amount of light the eye can detect, and especially the size combined with the yellow pigmentation helps it tell the difference between just ambient light up there and reflective camouflage from organisms like lanternfish and shrimp and other things that it wants to eat. And so the researchers are looking at the squid and are like, why did you evolve two eyes? Everything else is symmetrical. And their only guess is that it's biologically taxing to devote energy to two giant yellow eyes, which like presumably could also look down and see small flashes of light. And so instead of having both eye adaptations, something weird genetically flipped and it has two distinct eye adaptations so that it only has to put energy into specializing one and the other one can be boring and like relatively low energy for a vision organ. And that's just weird because there aren't many asymmetrical animals in nature, but the squid is like, I got you. Apparently there is a lot of eye diversity in this
layer of the ocean, though, because the light situation is so varied. So this is one of the most eye diverse places in the ocean. You're going to have a lot of weird eyes here.
It looks diseased.
Yeah, a couple pictures do a really good job of showing how big and weird the big eye is. Did squids develop eyeballs? They must have, separately from us.
It would have had to be so long ago where we developed eyes.
We are not closely related to squids.
Invertebrates.
Yeah. Squids evolved from like clams. We did not evolve from clams.
We all got there in eyes except for plants. What the heck's wrong with plants?
The plants can detect light in some ways.
Yeah, they don't got balls, though.
They don't got balls. It's true. Steph, thank you for making that clear. All right. Sam, do you want to vote with me on what your favorite fact is? 3, 2, 1.
Stefan.
Oh,
interesting.
Oh my gosh, how are the turntables? Now it's time to ask the science couch, where we've got listener questions for our couch of finely honed scientific minds. It's from @FoxNarutoMax. Why do we only have the regular circle pupils? I want pupils like cats or like frogs. Is that so hard?
There are different hypotheses as far as pupil shapes, but it seems like a lot of people refer back to this one 2015 paper in which researchers studied 214 terrestrial animals. So did not count the fishes and the sucking into your eye guitar fish or the cockeyed squids of the world, and sorted different eye shapes and how they got their food. So there's like vertical eyes, circular eyes, horizontal eyes, like we've been talking about. And then there's herbivorous animals, ambush predators, or active is the other category, which I'm guessing is just like actively scavenging. Maybe they're like omnivorous. And they found that there's a relationship between the ecological niche and the pupil shape. So herbivorous animals, so like the goats of the world, are more likely to have horizontal pupils. Diurnal predators, so you need more variation between day and night, have circular pupils. And then nocturnal or polyphasic, sleeping during the day, predators have vertical pupils. So it depends on what kinds of eye muscles you need to control light during the times of the day that you find food. And so it's like your eyes specialize to when you're awake. And so probably like the behavioral cycles of your circadian rhythms and those patterns of like when other members of your species are awake and when you can forage for food and when you can like be social and when you need rest, then had an influence on eye shape because the muscles of your eye adapted to when you were awake.
Well, what is interesting to me is that it seems like if you're going to make a thing that can contract and expand, circle is by far the easiest shape to make. But it seems like that doesn't matter that much because vision is such an important sense that it's like, whatever works best, we will invest the evolutionary, like the advantage will matter so that the like different pupil shapes will happen. To the point where like goat pupils, I'm like, that doesn't seem possible. It isn't. I don't understand physiologically how the muscles create a rectangle.
Yeah, and like the advantage that these researchers think it gives, and I guess we can only simulate other eyes. We can't necessarily like see through them yet until we have a neural link technology so we can see inside their brains. But the rectangular eyes help them get a more panoramic view, kind of like you were describing, Sam, where they can like adjust for the horizon so they can watch out for predators that are around because they don't really need to see the grass, so they can have like a wider range of vision than us. Or in the case of cats, they can like really laser focus in on what their prey is as they ambush or get a lot of light if they need to. Like if you've ever seen a cat in the dark, they're just like big eyes.
Big eyes. They got those big eyes. It's really cute. I like it when they get real dilated. But why do we only have the regular kind? It's because we're all related to each other and it was advantageous to have the regular kind. But I'm not saying to give up on your dreams, Naruto.
I am saying to give up on your dreams. Unless you want like a colored contact lens or something like that.
All right. Well, especially for a ninja like Naruto. A cat eye would be much more useful, I think.
If you want to ask the Science Couch your question, you can follow us on Twitter at SciShow Tangents, where we'll tweet out topics for upcoming episodes every week. Thank you to at Hemoglobed, at Actually Gimli, and everybody else who tweeted us your questions this episode. Our followers and listeners have the best Twitter handle aesthetic. All right, that brings us to our Sambuck final scores. Sari has 1. I've got 2. Stefan has 3, and Sam has nothing. Which means that Sari and Stefan are still tied. Is that right? And also, somehow Sam is now like almost all the way back there with me.
Doing a really bad job. Yeah.
If you like this show and you want to help us out, it's easy to do that. You can leave us a review wherever you listen. That helps us know what you like about the show. And also, maybe there's an algorithm somewhere that's like, delicious. Second, tweet out your favorite moment from the episode. And finally, if you want to show your love for SciShow Tangents, just
tell people about us.
Thank you for joining us. I've been Hank Green.
I've been Sari Riley.
I've been Stefan Chin.
And I've been Sam Schultz.
SciShow Tangents is a co-production of Complexly and the wonderful team at WNYC Studios. It's created by all of us and produced by Caitlin Hoffmeister and Sam Schultz, who edits a lot of these episodes along with Hiroka Matsushima. Our social media organizer is Paula Garcia Prieto. Our editorial assistant is Debuki Chakravarti. Our sound design is by Joseph Tuna Medish, and we couldn't make any of this without our patrons on Patreon. Thank you. And remember, the mind is not a vessel to be filled, but a fire to be lighted. But one more thing. Between 2015 and 2018, scientists in Botswana took 683 cows and painted eyes on their butts to see if they could deter predators. They compared the fates of these cows to a group that had cross marks painted on their butts and a group that remained completely unpainted, and found that none of the butt eye group were killed by predators. Meanwhile, 4 of the cows with cross marks and 15 of the unmarked cows were eaten. The theory is that lions and other ambush predators see the eyes and think they've been spotted, and so don't even try for it.
I want booty shorts with eyes on the back of them.
Yeah, and it's like, I know what you're doing. I know what you're doing.
I think that'd be great. That'd be my new favorite, like, I'm going for a run outfit.